Good morning. Very well said by Ronald Coase, and I quote, Good morning. Very well said by Ronald Coase, and I quote, Torture the data long enough and it will confess to anything. Just as nature is incomplete without its five essential elements, that is, air, water, earth, and fire, I think so is data to all of us. Today, we live in an era where data is one of the most essential elements. It is the fuel that drives our engines. It is the science of our being and is now the new soil. I am Reba Khan, lecturer at the Department of Information Technology, and it's a great honor for me to host and inaugurate this special event today and be present here with all the curious minds to unfold and unveil the mystery of data. We are at the Research in IT 2022, an initiative by the Department of Information Technology and Computer Science of Chikitsak Samuha's Sir Sitaram and Lady Shantabai Patkar College of Arts and Science and VP Varde College of Commerce and Economics. Thank you very much to all the viewers who are watching us live from across the globe, and a huge round of applause to all the hands working behind to bring this event live. This is the 13th year of the landmark event Research in IT, and this year we bring to you the need of the hour with the title theme Data Driven Decision Science. This is a special year for all of us, and it's a big one because we're talking data and big data here. Okay, before we start, let me very quickly introduce you to our college. Chikitsak Samuha Sir Sitaram and Lady Shantabai Patkar College of Arts and Science and VP Varde College of Commerce and Economics was established in the year 1964 and has been and will still continue to be one of the prestigious colleges in the western suburbs of Mumbai, India. I'm very pleased to say that we're now an autonomous college. We have been re-accredited an A plus grade by NAC third cycle with an institutional score of 3.53 in the year 2019. We as a college hold various aided as well as self-financed courses at both undergraduate and postgraduate level, including both diploma and certification courses. We've also received an approval in starting our PhD. Our college is an ISO 9001-2015 certified and DBT Star Scheme awardee. We're an achiever of India's Education Excellence Award 2018 from Berkshire Media, USA. In April 2020, as per Education World India College Ranking for 2020-2021, we hold 45th All India rank and 10th in the state of Maharashtra. As I said, the program we've gathered for is an initiative by the Department of Information Technology and Computer Science. I'm very proud to say that we are affiliated with the Computer Society of India, CSI, as an institutional member. With that said, let me welcome the presence here today of our Honorable In Charge Principal, Dr. Triza Joseph, Honorable Chief Education Officer, Dr. Mala Kharkar. I would also like to note the presence of Chief Coordinator, Ms. Ruchita Dalvi, Coordinator of the Department of Computer Science, Ms. Namrata Kavle Shinde, and co-coordinators of the Department of Information Technology, Mr. Chayan Bhattacharjee and Ms. Pooja Shinde. Let me also welcome all the faculty members of the Department of Information Technology and Computer Sciences. I may now request our in charge principal, Madam Dr. Triza Joseph, to please say a few words.
Thank you, Rima. On behalf of Chikitsak Samuha's Patkar-Varde College, I welcome you all to this RUSA-sponsored international webinar on Research in IT 2022. Data-driven decision science organized by the Departments of Information Technology and Computer Science. We at Patkar College are constantly upgrading our courses and infrastructure to provide students with the best possible learning opportunities. In keeping in line with the vision of our institution for holistic development of the students, various departments organize webinars, workshops, and conferences. And today, the Department of Information Technology and Computer Science have jointly organized this international webinar on Research in IT 2022. I welcome the resource persons of this webinar, Ms. Sheetal Kedia, Senior Consultant at Capgemini, and Bastian Robin, the Chief Data Scientist at, at Clever Insight, Bangalore. I thank the management of Patkar College, Honorable President Shri Kishore Rangnekar, Honorable Secretary Dr. G.V. Pandit, and our CEO Dr. Mala Kharkar for their continuous support and encouragement always. Wishing you all great success. Thank you.
Thank you very much, ma'am, for your wise words. Okay, so let's now get to the event. We have two phases running for this event today, and for you, we have two of the most eminent people in the field to talk about data driven decision science. I would like to introduce you all to our phase one speaker for today, Ms. Sheetal Kedia. Ms. Kedia holds more than 11 years of experience in the field of investment banking, data warehouse domain concerned with handling ETL of insurance domain. She pursues great expertise in data warehousing, ETL concepts, business intelligence tools, and languages such as Informatica Power Center, BODS, and many more. Ms. Kedia has also been very proficient with database technologies such as SQL, Oracle, Greenplum, and NoSQL, MongoDB, and has also worked on creating several data cubes. She is a huge repository of data warehousing and has a great exposure on reconciliation projects in investment banking domain. We are very delighted to have you on board with us, Ms. Sheetal Kedia. So, dear listeners, keep your ears wide open because, as they say, and I'm very sure you also will agree to this in the near future, data will listen to you if you are willing to, data will talk to you if you're willing to listen to it. Ms. Kedia, you may now please begin.
Thanks, Reba. Thanks, Miss Ma'am. And thank you, everyone, for coming here in this early time. Let me start by sharing my screen. Can someone confirm if anyone can see my screen? Okay. Hi, everyone. Have a very good morning.
Yes, Sheetal ma'am, your screen is visible.
Okay. Thanks, Reba ma'am, for the confirmation. Hi, everyone. A very good morning, and thank you for your presence in this on Saturday morning. It's really valuable to us. And thanks, Reba ma'am, for the introduction that you provided. I am Sheetal Kedia, a senior consultant and a data engineer with 11 plus years of experience throughout in the data field. I would really like to take this session in person, but given the situation, I guess online is the world. So yeah, here we are. But feel free to post your questions anytime in the comments. Having said that, let me start with my topic today. That is nothing but data architecture evolution. Okay, so I will again like to reiterate or re-emphasize the value of data that Reba ma'am in the beginning of the introduction did stress out that. That means data is really important. It's really huge, and it is a lubricant in today's world. Nothing is possible without data. Okay, so this presentation is entirely based upon that. I'll start with explaining what is data, some basics of data. Then I will deep dive into what is data architecture, and ultimately going into my main topic, that is how data architecture evolved over the years. So let me begin. I already covered this. Okay, today's agenda. So let me go to my next slide and explain you what we have here. Okay, so what is data? Okay, that's a really basic question to answer, right? So data is nothing but just two digits, a zero and a one. Essentially, it's a two digit, a 0 and a 1. But in reality, there are a lot of combinations of zeros and ones that are lying around. And in logical sense, when you say my name is Shitalkadia, that's a data. I have hold a bank account in XYZ bank, that's a data. Today's stock market is like 10,000 points, that's a data. So all this small information is data. So imagine in this world of 7.9 billion people, if this small information is data, then how huge data world we live in, right? So what do we do with that, right? There is something called as information that separates thing from data. Okay, when I say an information, which means a specific thing which is meaningful to someone. Okay, so if I go to a bank, if I say, okay, I have some of my health issue, they don't care, right? That's not an information to them. But if I say I have 10 lakh rupees and I want to create a fixed deposit, they will be interested. That's an information to them. So that separates data with from an information. So that's what we have data for. Information is really important in real world to gain insight into many questions that businesses have in today's world. And saying the data is growing like a beast, getting information out of this data, it's really painful, but even really curious, interesting thing to do. And now as we have data problems. You can see this lady over here, she is really frustrated, and that's how the situation is in the real world, let me tell you that. Data problems in real world is like crazy. There are like a lot of garbage data, I can say, that's lying around, which is not useful. But there are so many useful things within those unuseful data. So getting the sense, making the sense out of that, it's really a huge issue that the current industry is dealing with. Okay, and then there are these users who are constantly, users are nothing, no one but data scientists, data analytics researchers, right? People like us who are trying to make some get some information out of that data, make some sense out of that data, so that they can use that thing in making their business grow, their business better, getting some insights to predict some stock market thing, what stock's going to be like in the next few years or next few days, whatever it is. So those users do need really good data to make that decisions. So that's what we have in data problems and users. Let me move on to my next slide. Okay, so here comes database. I guess most of you, being a student, would be aware of what is a database, but let me reframe them that still. If I go by definition, a database is nothing but an organized collection of structured information or data, okay, typically stored in any form, be it a file, be it a table, but it's a systematic collection of data. So basically, if you have ever created an Excel sheet with some table in it, you have already created a database of data. Database can be in any form. Be it in Oracle, SQL Server, Microsoft DB. It's a database. Be it an Excel, even if it is a file, it is a database. Okay, so that's what we have, a structured collection of data. Okay. So when you complete a Zoom call, most of you will be online, studying online these days, right? And I guess many of you might have experienced, after every Zoom call, they would say, how would you rate the experience? Okay, you say whatever you click, that's a collection of data. That's like Mr. XYZ has said that he's satisfied with Zoom. That's a data that's getting collected. When you create a free account, that's the same thing happening. So this database do have a really great usage down the line for the data architecture, data modeling, for data users, everyone. So it's really important that database is chosen wisely, and the data is stored very wisely. Let me move on to my next slide. So now, as we have covered the basics of data, basics of database, what are the users, and what are the problems that we can face. Let's see what is today's thing, right? What is today's topic? To start with, even before I start this topic, data architecture, I would like to tell you, I may have some challenge for you once this presentation ends. So please be active in listening. Okay. Okay. When I say data architecture, what does come into my mind? Come into anyone's mind? Have you ever seen a person or a building getting constructed, a college getting constructed? It's not like I just get 1,000 acres of land. I just get some contractors and I say, okay, I want to build a 10-story building over here. Please start. If I do that, that will be a complete mess. But rather, what do? We hire civil engineers. They have a paper, pen, computer. They use their knowledge uh, on deciding what factors should be there, how the foundation should be built, how much area should go into parking, how much area should go into fire drilling system, so that in case of emergencies people can vacate. So all these kind of things are decided first, even before going into building a constructing a building. So that's what a civil architect does, right? So that's called as civil architecture. In the similar line, in a similar fashion, data architects do develop an enterprise-wide data architecture. Okay, so then similar to what civil architect does, we do have a lot of pillars when it comes to data architectures. So basically, like security, infrastructures, who are the data consumers, who are the data producers. So all these things, where all we will be getting the data. How will I get the data? What are the rules to get the data? How will I model it? So there are a lot many questions that goes into when it comes to storing a data into a database. Okay, it's not like, okay, I'll just get the data and I'll just dump it. It cannot happen that way, because if it happens that way, it will be a complete chaos and no one will be ever able to access that data. So there has to have a certain set of rules and policies that is governing this data that is getting stored, okay, to make everyone's life easier. So let me read out this definition for you. So data architecture is nothing but set of rules, policies and models that determine what kind of data gets collected and how it is used and processed and stored within a database system. And the main few pillars that I would like to highlight over here for data architecture would be security, as I already mentioned. So security helps ensure that the data that we are storing is secure enough. It's not leaked. It's not accessed by hackers. So those that is one of the pillars. How data acquisition? How do we acquire this data? How do we read this data? From what sources do we read it? Is it YouTube live streaming? Is it a video file? Is it an audio file? Is it a point of sale system? Is it from somewhere else? So from what that is from where we acquire the data. Infrastructure. So infrastructure in the sense, what am I going to use to store that data? Is it a NoSQL database? Is it a SQL database? Is it an Excel file? How am I going to process the data? Is it Python? Is it Java? Is it some XYZ tool? What is it? So that's infrastructure. Then who are all will be my data engineers? What level of data engineers do I need? Do I need senior data engineers? Do I need 2 architects, 10 architects? That kind of information. And then there are these data users who are data scientists and data analytics. What do they need? What do my data scientists will need? All this kind of information and decision makings go into data architecture. So this data architecture term was first published by Edgar F. Codd in a paper called as Relational Model for Data or Large Shared Data Banks. So basically it was introduced from banking domain perspective itself. So let me go ahead to my next slide to deep dive a little bit more into what is a data architecture, because this is what we have a foundation of today's talk, at least for this particular presentation. So you need to have a good understanding of what is data architecture. So I can see, you can see this picture is clumsy. So don't look at it like that. Start with the left, and then we will go ultimately to the right. Okay. What is in the left? In my left, we have data producers. And in my extreme right, we have data consumers. So what do data producers do? Data producer does nothing. It's like it's getting the data, it's generating the data. So, for example, when you go to a D-Mart, when you go to a lifestyle, you buy something, you go to a cashier, right? You get billed, and then that lady or whoever it is, they are putting something into the system. That's a transactional data. That is the data that is getting generated. Similarly, in the banks, when you go into a bank, you open an account, and when you open an account, you give all your personal information, and that account manager does the needful things. So that data gets captured. That is nothing but you are giving the data. That's a source. Okay, so those are all the transactional data. So there is a term for this called as OLTP. That is nothing but online transactional processing system, wherein all transactional data, that is day-to-day life's data, is getting processed or stored. Okay, those are the sources for those are the sources. That is the very first point when the data is actually getting collected. Then comes the data integration layer. That is the layer one, wherein I am trying to integrate the data that I'm getting from all the sources. Okay, I want to have it in one place. So I want to make sure that it's about data movement and transformation. All the source and target systems, all of that are in place. Once I have that in place, then I move on to data warehouse or data lake or whatever architecture that I choose. I will make sure that that data goes into that particular architecture. Then similarly, we have data integration layer 2, which is nothing but does a similar kind of functionality that integration layer 1 does. And then we have small data marts. Imagine data marts as nothing but a simple data storage as per domain. Okay, and what is domain now, right? So domain is nothing but a specialized area of function. So, for example, banking is a domain, insurance is a domain, retail sector is a domain. So domain is nothing but, I would say, it's a special functional thing or a subject oriented thing that accesses the data. So data mart is specific to subject oriented data sets. Okay, and then ultimately we have the data consumers, who are nothing but data scientists, researchers, data analysts, who depends on the reports and analytics, basically who depends on the data to generate the reports and analytics, to make sure that whatever business decision they are going to make, or CTOs or CFOs or CEOs of a company makes, they make a wise decision based on the reports that they generate. So can you see this downward strategy, right? So CEO makes a decision for the company. CFOs make a decision for the company. They make the decision based on the insights or the business intelligence that is given by these data scientists, data analytics people, right? And these data scientists and data analytics rely on data engineers or on data engineers, right? On this data for generating those reports, those perfect reports, those sensible reports. So we can see this, how it is actually impacting, how data is impacting at a huge bigger level. Okay, so that's what the data architecture here looks like. And the pillars this is like this 5 things that is listed down here, which is nothing but metadata, master data, data quality, data governance, and data privacy. I guess I have covered few of this in the previous slide. Basically, like data privacy is nothing but data security. Data governance, I would say, data governance, to give you an example, it's just like an RBI, right? So we have several banks, and like SBI and Yes Bank, and a lot of banks we have, and those are getting governed by a central body. That so similar on a similar fashion, we have data governance over here. It's really important that someone governs the data. Otherwise, the data will be all lying around with no one to govern it, no one to rule it. Data quality is a really important factor when it comes to data architecture. The quality of the data is really essential to make a healthy decision or make a healthy data. If suppose if there is bad data coming in, and if there are spaces, there are unwanted characters, we cannot, the system may go mad. It cannot understand what's passed into it. It cannot make sense out of it. So it has to be really made sure that quality of the data that is getting generated out of that system is really really good. Then master data and metadata, it's nothing but so metadata, you might be aware, it's data about data. So it does help in kind of a governance thing. When we have metadata about anything, it does help in the governance thing. So let me move on to my next slide. And one more thing I would like to highlight before I move on to my next slide is data architecture is a concept, right? So this concept can be applied anywhere. So it can be an on in an on-premises database, it's in an on-cloud database. In today's world, cloud is a technology that's going widely used. That's widely used. So this is a concept that can be applied anywhere. Let me move on. So now here starts our generation thing, right? So data warehouse, it's really pretty old. It goes back in 1970s when Bill Inmon coined this term data warehouse. He was the first one to introduce that. So it all started with when there was this need, when there was, at those time, there was no live streaming unstructured data as much as it is now. And those time there it was a new generation of data that was coming in with all structured kind of data. And at that time there was a need that this data that is coming in, that should be stored or should be architected in some way. And that's when data warehouse was done. Sorry, that's when data warehouse was what to say, coined in by William Mon. Let's see what it is. So before moving on to my next slide, I want to know, the next slide is a video. Just make sure that you pay attention to the video, what's going on. I'll cover in depth what will be covered in the video. So make sure that you see this video with your full attention. Thank you.
Data warehousing is one of the hottest topics both in business and in data science. But if you're new to the field, you're probably wondering what a data warehouse is, why we need it, and how it works. Don't worry, because in 4 minutes, you'll know the answers to all these questions. All right, first, let's start with a definition. What is the meaning of the phrase single source of truth? In information systems theory, the single source of truth is the practice of structuring all the best quality data in one place. Let's look at a very simple example. Surely it has happened to you to work on a file and to create many different versions of it. How do you name such a file? Well, once you are done, you often place the word final at the end. This results in having a bunch of files with extensions. Final, 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 final. Or my favorite, really final, final. If this is you, you are not alone. It seems that even corporations never know where the most recent or most appropriate file is. But what if you knew that there is one single place where you would always have the single source of information? That would be quite helpful, wouldn't it? Well, a data warehouse exists to fill that need. So, what is a data warehouse exactly? It is the place where companies store their valuable data assets, including customer data, sales data, employee data, and so on. In short, a data warehouse is the de facto single source of data truth for an organization. It is usually created and used primarily for data reporting and analysis purposes. There are several defining features of a data warehouse. It is subject-oriented, integrated, time-variant, non-volatile. Summarize. Let's quickly go through these one by one. Subject-oriented means that the information in a data warehouse revolves around some subject. Therefore, it does not contain all company data ever, but only the subject matters of interest. For instance, data on your competitors need not appear in a data warehouse. However, your own sales data will most certainly be there. Integrated corresponds to the example from the beginning of the video. Each database or each team or even each person has their own preferences when it comes to naming conventions. That is why common standards are developed to make sure that the data warehouse picks the best quality data from everywhere. This relates to master data governance, but that is a topic for another time. Time variant relates to the fact that a data warehouse contains historical data too. As said before, we mainly use a data warehouse for analysis and reporting, which implies we need to know what happened 5 or 10 years ago. Non-volatile implies that the data only flows in the data warehouse as is. Once there, it cannot be changed or deleted. Summarized once again touches upon the fact that the data is used for data analytics. Often it is aggregated or segmented in some ways in order to facilitate analysis and reporting. All right, so that's what a data warehouse is. A very well structured and non-volatile de facto single source of truth for a company. If you
Hey, thanks. So, hope that at least it gave you a sense of what is a data warehouse. And I'd like to pass on the courtesy to YouTube for this video. Um, so, what is a data warehouse? Let's redefine what's a data warehouse. Okay, so data warehouse is nothing but a centralized location wherein all data is getting collected from different sources, and meaningful business insights are made out of those data. Okay, and there are certain features of the data warehouse that makes it special. Okay, so features like it stores all the historical information, it stores all the data in a denormalized format. There's no normalization concept in data warehouse. For a layman term, on a layman term, when I say a data warehouse, okay, so it's just like a database, or it may be any database, Oracle, SQL Server, any kind of database, okay, wherein some models are built, some entity relationship models are built, so that how the tables will be organized, how the data will be organized in a way that it satisfies certain rules that is defined by data warehousing. Okay, so what are those rules? Those rules are nothing but, as mentioned in the video, that is subject oriented, integrated, time variant, non volatile, and summarized. Okay, so let me deep dive into one of the every one of those. Okay, so you might have heard the term subject oriented before this when I was explaining data mart. Okay, so subject oriented means it revolves around something, some subject. Okay, be it when we are having sales data, so sales is a subject point. Okay, similarly when we are in a banking domain, when we are in an insurance domain, so premiums collected, or claims done, so all those are subjects. All the data for a data warehouse should be subject oriented. Okay, it should be an enterprise level data. Okay, integrated means single source of truth. There shouldn't be, so if there are, if suppose if you go to a store, buy a thing, buy a dress, okay, and you return that dress in next day, right, there are two transactions on your name. Okay, so your data warehousing system should show that two transaction, and the users will believe those two transactions are genuine because those is the source of truth. That's what is believed. It's time variant, so that means data doesn't change over time. Once the data is there, it's never deleted. It stays over there for 5 years, 10 years. It won't be ever changed. The only change that can be done is if there is any change in that data. For example, just now I said, like if you bought a dress today and if you return that tomorrow, then that data will be made sure that it reflects that change, that Mr. XYZ bought this day, bought this dress on 1st of December and returned on 2nd of December. So this data will be there after 10 years as well. Like even in 2030, if you go, it will be there. It won't be deleted. So that takes us to the non-volatile part of it. And then comes the summarized part. So this is an interesting summarized part. Why do we need to summarize the data? So in data warehouse, so okay, know we have online transactional processing system wherein each and every transactions are stored. Okay, so think of it like, suppose in a day there are thousand or tens of thousands of transaction happening, and in transaction processing system, it's continuously getting inserted. The data is continuously getting inserted into the table. When it comes to data warehouse, okay, we have to make sure that this data is also accessible to data scientists and data analysts for their reporting purpose. Okay, and if querying on such a big data can be a problem for them, they may not need those level of details. What they may need is, okay, so in Mumbai, for in Mumbai, I made, or this company, ABC company, made a sale of $10 million, or this company made a sale in Delhi of $20 million. So just that level of data this guy may need, the data scientist or data analyst or researcher may need. So instead of doing that summarization on the fly, we why not just summarize and make that aggregated to give meaningful business insights to the data scientists. So let's summarize and store that data. So that's one of the important feature of data warehouse. Let me move on to my next slide. That is extract, transform, and load. Okay, so how did this extract, transform, and load came into picture suddenly, right? Um, Data warehouse. When you say that I want to store a data into data warehouse, there has to be some process, right? So what is that process? How do I do it? How do I store it? That's nothing but extract, transform, and load. That's what called as an ETL. That's generally referred to as an ETL process. Okay, there are multiple ways to do it. There are hundred of ways to do the same thing, but the concept is really same. So, and it's really self-explanatory by the terms. If you go by the term extract, okay, when I say extract the data, get the data from all the sources that is possible for me, or that is meaningful for me, not possible, but that is meaningful for me, be it databases, be it CRM, ERPs. So CRM, ERPs are nothing but those are systems, customer relationship system, and those are systems. So get those data from there, or web events, whatever data means meaningful, extract those data. Maybe pull those data or push, or source may push it to us, be it anyway, but extract those data, get that data, extract this is get that data into our system. Once we get into our system, it is getting loaded into staging area. So staging area is nothing but a place wherein we can transform all this data. Whatever we need, this all raw data that we are getting from source, we want to convert it in some way that it would be fitting into my data warehouse. Right. So if I said that, for example, if I give in a banking domain, right, I work in a banking domain. So I used to work on investment banking. So in that, we used to get a lot of what you say, stocks, option, futures, all those sales and purchases data on daily basis. But what we wanted to report was, okay, for foreign exchange, for this particular currency, this money for this, for my bank, whatever I was working for, this bank made a transaction of this much in on foreign exchange of America, or on foreign exchange of Europe, whatever it may be. So I just want that data. So that kind of transformation I have to do, and it can be done using various tools. We used to use Informatica. That's one of the tool, Informatica Power Center. That can be a lot of tools to do that. Okay, so that is called as transformation. We change the data, and there are multiple phases even in transformation. So first we load the not load, sorry, we get the data, load it in a staging area. That's a temporary area, and then we clean the data. So whenever we have data, we have to make sure that's a clean data, right? There are no spaces, there is no unwanted things in the data, so that I can make more sense out of it. I can do a better aggregation out of it. I won't face. So basically, a numeric field should have only numeric. It should not have a string. A null field, a not null field should have only not null. It should not have any null value. So all these kind of data quality checks, right? You might heard the term in data architecture, that data quality checks. All these things are done while transformation. Okay, and once my data is transformed, it's very good form, I load it into my data warehouse. Okay. So that's the last part of ETL, that is loading into the data warehouse system. So that is now prepared. Now my data is readily available for use. Now that can be used by any number of BI tools. So there are a lot of BI tools. BI is nothing but business intelligence. So business intelligence is getting the intelligent like, business out of this data. Okay, intelligently building the reports out of this data. So there are a lot of BI tools. For example, business objects is one of the tool that is from SAP. There is Spotfire, there is Talent, there are a lot many tools in the industry. Okay, every company uses it differently, but the ultimate aim of all those BI tools is the same, that is making the sense of the data. So just to give you a view of what is a BI tool, so here is a sample BI tool that sample report in a BI tool, I would say. So as you can see, there's a pie chart, there is a line graph, there is a bar graph. And as you can see how in it shows the quarter one result, how much increase that got 24.86, quarter two 26.61. Similarly, how this quantity sold changed from New York to Miami, right? Sorry. And how does the margin of a company varied over the period of time or over the different what you say trouser dresses that were sold out, right? So these are really important data that is used by business people to make a really good decision and to see the company growth. So it's really important. So but however important it may be, there are some challenges to it. Challenges to this data warehouse. What is that? Okay. So as one of the important and biggest challenge, I would say, even before going into whatever you can see on the slide, one of the very important challenge I would say in today's world is data that was getting generated in 1970s, 1980s was really very different and very less comparatively to what it is now. We did not have WhatsApp, we did not have these online streamings as much as we have now, right? So there are huge data, and data warehouse was not built to handle those kind of thing, those kind of unstructured data. Okay, it can handle structured data for sure, but not for unstructured data. And over the time, maintenance get costly. So as we know, data warehouse system is a historical system. The data doesn't get deleted, right? It stays there for 5-10 years, which is a good thing for business, because sometimes business may want to see what happened 5 years back and 10 years back, and they can use that strategy. Suppose in 10 years back it was doing really good, and 5 years back it was not doing good, or today it's not going good, it will go back to 10 years data and we'll see what it was doing so that it was good. So it's really helpful, but maintaining that data gets costly, right? It gets increasing over time, the data gets increasing over time. Then there is scalability issue. As I said, as I just mentioned, like the data is huge now, it was not that case. So that is also one of the challenge in traditional data warehouse. And to address all of this concern, something came up. Someone brought up the term which is known as data lake. So data lake was coined in I guess 2010 by Levis. He was working in Pentaho. So this data lake addressed some of the problems or some of the challenges that was faced by the people who were using data warehouse and who had a growing number of data and they were not able to cope up with that. So let's see what is a data lake. Okay. So by this term itself, data lake, what is a lake? Lake is nothing but um, water body, right? Wherein we have all kind of things dumped at once. So similarly, data lake is nothing but all kind of data, whether it's a semi-structured, structured, unstructured. So unstructured data can be anything like video files coming in, image files coming in, Semi-structured data will be like log files, that are network logs getting generated each and every moment. Now we are talking, right? Now this live streaming is going on. There are comments that are coming in. So those comments are getting logged. This transaction is getting logged, whatever we are having. This is also data, right? So all this kind of data are getting stored in data lake as it is. Okay, so that's a very what do you say, a different point of data lake than that differentiate data lake from data warehouse. Data warehouse used to deal with structured data, that it has to have a structured format of data that it can read, then we can cleanse the data, we have to transform the data. But here, whatever we are getting from the web, world wide web, just get it. So that's what we are doing in data lake. Once we have the data, okay, once we have the data, then after that, when data scientists want to use that, wants to make sense out of that, that's when the transformation is getting applied. That's when the data is getting made usable to the users. Okay, so these are the three phases of the data lake, that is ingest, store, and analyze. Okay, so I will like formal definition, I'll just go on from a formal definition of a data lake. So a data lake is nothing but a centralized repository. Okay, this is a good point of centralized repository. As of now, what we have seen, data warehouse, data lake, both are centralized repositories. So centralized means at one place. In data warehouse as well, we just had one place wherein we stored all the data. Data lake also has just one place wherein we are storing all the data. So it's a centralized repository at one place, which is designed to store, process, and secure large amounts of data. I mean, whether it's a structured, semi-structured, or unstructured, it doesn't matter. It stores, and it can store it in native format, whatever the format it is. It's a JPEG image, it's an MP4 video file, it's an .log file, or it's a World Wide Web, some different kind of file. Any native format it stores, and it can process any variety of it, ignoring the size limits. So that's a really underlining point, that is ignoring size limits. Okay, because that was one of the challenges for data warehouse, that it was not scalable. Here, that's the solution to it, that it's ignoring the size limits. So the next slide will show you again a video. It's a small video than the previous one. Let's go through that. I'll see you in a meanwhile.
What is a data lake concept? Well, a data lake is an element of big data infrastructure centralized storage that accepts, organizes, and protects large volumes of structured data, unstructured data, and semi-structured data in their initial format. How does data get into the data lake? Business analytics or data scientists start by identifying significant or interesting data sources. They then replicate data from selected sources into a data lake with little or no structural, organizational, or formatting changes. Data arrives in two ways, such as batching, which means loading at intervals, and streaming, meaning data stream. The multi-step process used to receive raw data and prepare it for later use is abbreviated as ELT. That stands for extract, load, transform. Who needs data lakes? Any business that accumulates large amounts of data requires data lakes. Among the people that can work with data lakes are business analysts looking to track business performance and create dashboards, researchers analyzing network data, and data scientists using prediction algorithms from massive data sets. Let's take a look at prevalent features of data lakes. Among the features we define, separate storage and compute. It makes it easy to parse and enrich data. Customization and interoperability, open source technologies, which helps reduce dependency on vendors, powerful support for distributed computing for large-scale processing of data, ability to process all data types, and maintaining complex non-SQL programming models.
Okay, so that was something. So let me move ahead. Okay, so now it's a different term called as extract, load, and transform. Okay, so here what we learned before this was extract, transform, and load. Now you can see one difference, that it's a load first and then there is a transform. Process is same, The difference is the loading part is done first and then the transform part. So here, as you can see in the diagram, the data sources are same. Data is extracted in its raw data, in its actual data form. Okay, and then it's getting loaded as it is. Whatever was read, it is getting loaded as it is. And once it is getting loaded as it is, then it is transformed. That is prepared. So now you can see one interesting term over here, that is Hadoop. Okay, so it's one of the technology that has been invented to deal with a huge data, or that's a big data. Okay, so as of now, whenever there is this live streaming data and everything, right, those data are all gigabytes or terabytes, and to query such unstructured semi-structured data, there has to be special treatment or special way to do it. And Hadoop provides that infrastructure, or Hadoop provides that base for this kind of data to be queried upon. Any kind of unstructured data can be queried upon. So Hadoop file system is really good and really efficient and faster to manage this, to store this kind of raw data. And this can be, and just to reiterate this, it can be in cloud, it can be on premises, it can be wherever. Okay. So once it is loaded, then it is raw data is now getting transformed to a prepared data, which can be used by analytical tool or the BI tool, which we already discussed, right? So, so that's what we have ELT for. That is extract, load, and transform, which is different from extract, transform, and load. These two methodologies are very specific either to data warehouse or to data lake. One interesting term you might have heard in the video would be data streaming, and data batch processing and stream processing. So what is a batch processing? In data warehouse, we get data. Okay, we get data from transactional system. Okay, then there would be, those data will be processed in batches. That is, they will be processed together at a given time. It might be nightly jobs. So every night there will be certain job that would be scheduled to run. That job will do this extract, transform, and load thing. Or it can be weekly jobs, that is on weekend. The essential point to be noted over here is that is run off of business hours, so that we have all the essential data, that is all the essential data available to us at the end of the day when we process the data. So that's a batch processing, that is processing the data in batches. And stream processing is processing the data as it is coming in. So like this raw data, right? So as soon as we get the data, we store the data and then we transform it. So that's a stream processing. So data lake can be, you can be there, or it can be used to deal with both kind of processing, basically batch and stream processing. Okay, let's move on to next slide. That is challenges with data lakes. So as for data warehouse, we had some different kind of challenges that somewhat is overcome by data lake, and now data lake, we are facing some different kind of challenges. What are those? Data lake can easily turn into data swamp. Now, what is this new term, data swamp? Data swarms are nothing but when we have so data lake is just collecting all these semi-structured, unstructured kind of data, right? That's what we define the data lake as. So data swamp can be getting this huge amount of data, okay, which can be without organization. That can like, unfortunately, it can become a wasteland of data because we are just getting and getting without clear organization. There can be in many cases there would be many copies of the same data, or there can be irrelevant data which are gathered and just dumped in the storage. It's just lying there, occupying the space without having getting used, or it may sometimes give even the wrong impression. So those are called as data swarm. So basically, essential data may get lost in those copies of irrelevant data, as we are just storing as it is without any cleansing, without anything. So that is one of the challenges with data lake. Another challenge is not following asset property. So what is an asset property? So you may know that whenever we perform any database activity, right? Whether you have doing an insert, delete, update, there has to be atomicity, consistency, isolation to that transaction, right? So it should be the transaction or the insert, the particular updates should be treated as it on its own, should be treated on its own. It should not be like if you are updating and someone else is also updating, those both should not clash, and it should be consistent. That the updates or the changes that you're doing should be consistent. All those properties are not followed in data lake because we are storing the dump data as it is, right? That's what we define the data lake. So it can sometimes yield some problem that we usually see in the data that do not follow acid property. And then one of the important thing is need specialized skills to manage and handle data. So data lake handles all kind of data, right? Unstructured, semi-structured, and it can have video, images, files. So one of the tool that I mentioned was Hadoop. Okay, so all this handling of all this kind of data needs special skills, special resources. So using Hadoop needs specialized skills. Finding those kind of resources can be really challenging sometimes, and it may be really costly as well. So that's the reason that's the reason it's listed as in challenges, because those can be hard to find skills and those can be expensive to have skills. So those are some of the challenges with data lake. Let's now move on and see how the next generation data architecture handle these challenges. Now we are towards the data mesh. Okay, so what's going on with the data mesh? What is it? Okay. Data mesh was coined by in 2018. It's like more recent. It's 4 years back. It was coined by Samak Dehavgani. She's from ThoughtWorks. Okay, so it also does a batch and stream processing. It also handles both kind of data, and it's mainly towards the logics on how do we handle data over here. Okay, let's see how does it happens in data mesh. What is data mesh and how do we do it in data mesh? Again, this diagram looks clumsy, so don't just look over the clumsiness of this setup. Just let's concentrate on this particular part over here. Let's what is it. If you can observe one thing, this circle, this particular three boxes, two circles and one hexagon, is getting repeated over and over. It's getting repeated. So what is this? What is this particular small circle? This is nothing but a small domain or a small team that is working on its particular domain. So there is a small team which is getting the data from the sources, changing it, and handling it to the users. Same thing is getting done here. So for example, now we have a banking domain, right? In the banking domain, we can have we can have a lot of subdomains. Okay, and that those subdomains can handle the data in their own way. So for example, in a company there can be a marketing department, and marketing department do deal with the streaming, online streaming data, right? So for example, here you can see this Hadoop thing, right? This little elephant is nothing but that indicates Hadoop, right? So which means this particular team, whichever is sitting here, will deal with online streaming data. Whereas this team sitting over here do not need to deal with it because they do not care about streaming data. They are administrative department that just deal with the personal information or personal information. So they do not need to worry about it. So this one thing that you should observe in here by looking at this diagram, which is different from the other two, is it's a decentralized. As of now, whatever we have seen, it was just one single flow with one central thing. Here, the thing is, these things are decentralized, with separated with small domains, with each domain giving its own output as a data. Okay, these domains are interconnected to exchange data on their own, because administrative department cannot work in a silo than a marketing department. They have to somehow connect to get the information, right? So they have to give the data. One of the essential point of data mesh is like it should be, the data should be treated as a product. So as of now, what we were getting was, we are getting the input from data sources, we are getting the output in kind of some form of data, whether it's a summarized, whether it's a data lake, or it's a granular, whatever it may be. But it was just some kind of data, and analytics people, that is researchers, data scientists, and everyone, we're using that data. We're using those data as it is. But here, first thing is we have individual users for each domain, and next thing is those data are given as a product. So when I say data as a product, what do I mean? So for example, some senior students may know they have to build a project towards the year end, right? At that moment, you have, suppose you're creating an app, a mobile app to manage the library management system. So what do? You create a front end, you create a back end, then you take input, you give functionality like search for library books, search for the availability, keep a hold on the book, all those kind of speeches you give, you store the data in the database, and you give this entire application as a product. That's a product that you're giving as an output, right? And data is just a byproduct of that application. Whenever user enters a data into that application, that data gets generated. That's a byproduct. But the concept, one of the important concept in data mesh is, this team needs to treat data as a product. They should give data as a product. It should be a wholesome data, so that it can be readily used by other teams or other people. So that's where the data mesh concept is. That's what the data mesh concept essentially is. Let's look at the definition. What is a data mesh? Okay. So data mesh is nothing but it refers to the decentralization and distribution of data ownership. Okay. So decentralization, I will stress out this word because you might have noticed on centralization on the previous two topics, data lake and data warehouse, right? So here it is decentralization. Distribution of data ownership. So now data ownership is getting distributed among this various team. So this team is only owning data for administration data. This team is owning data only for marketing data, it is online streaming data. So all this decentralized and data ownership is distributed both at technical and organizational level. So not only like just coding perspective, even at organizational level, when it comes to CFO, CTO's level, right, or organization level, it's owned by a separate people. And that's why the users, it lets users do away with the challenges involved in the accessing data. So for example, a data scientist, okay, take an example. A data scientist is given a full set of data which has everything. Okay, will it be easier for him to access all those kind of data at once? Or if we assign a specific data scientist to a particular marketing domain, so for example, to get insights in the marketing domain, and we just give the marketing data to him and ask him, okay, get me the insights of the data. So what will be easy for him, right? It would be getting the data which is specific to them, or which is very specific to it. So that's how it lets user do away with one of the challenges of accessing the data. Okay. So one interesting thing about data mesh was, the lady who coined this term, uh, there's a very big European company, commercial company called as Zalando, and who did was using data, like they actually were started with data warehouse, using data warehouse, then they moved on to data lake, and then they moved on to data mesh. So there is a video I can share the link at the end of this presentation, so that you will get an idea of in actual world, or in actual enterprise or in actual industry, how does this change happens and how does it matter. So let me go with principle of data mesh. What are the principles of data mesh? Okay, first principle is domain oriented decentralized data ownership and architecture, which is nothing but it will be owned by a person, a separate data team, its own data team, and it would be domain oriented. And by now, you should understand what is a domain. A domain is nothing but a specific subject area that is specialized, or that is just concerned about those kind of information. So that is one of the very basic principle of data mesh, that is domain oriented decentralized data ownership and architecture. Architecture is owned by the domain team, the data ownership is owned by the domain team. Second, one of the very important, data as a product, which I already explained you, that data as a product is nothing but having the data, making sure that the data that is given is not a byproduct. That is very clear. You should give data as a wholesome. Okay, when you say we are having this data, we are giving this output, it should be given as a whole data. Self-serve data infrastructure as a platform. This is really while reading this, it may seem complicated. Okay, so let me divide this thing. Data infrastructure. Okay, what is data infrastructure? Data, what is infrastructure? Infrastructure is something wherein everything is based upon or built upon. So basically, if I say Oracle, right? When I have Oracle database, so Oracle database needs to host servers, right? So that is an infrastructure thing. Okay, so similarly, now the problem that can arise in this data mesh is every database, every small thing is different, right? So if they have their own infrastructure, then it would be really difficult for a central coordination to happen, because suppose this team is using Oracle, this team is using NoSQL, this team is using SQL Server, this team is using something else, right? How would someone manage, right? So it's really important that data is served, or it's served as a it's self-served as a data infrastructure, as it's a platform. Okay, then comes federated computational governance. And this is, again, I would say it's really important, just because it's a decentralized database. In a centralized database, it's really easy to govern because it's just at one place. We can apply all the rules at one place. In a decentralized, it's really, really important that all these small chunks are governed by things. It's just similar to the example that I gave you previously of an Reserve Bank of India. So that there should be federal governance like in between, that should abide, like everyone should abide by the rules of this governance, so that whatever data is shared is consumable. So, for example, right, if administrative team says, okay, I'll give you a file, I don't care what do you need, I will just give you a file of data. But marketing that cannot use it because it's not capable of reading a file. Might be, it may be, or it might not be, right? So the central federal governance, whatever we have, federated governance, that says some defined rules. Okay, if someone shares the data, it is how it has to be. It should be consumable by everyone. Okay, no one can do on their own. It has to be governed by some policies. Okay, so let me next. Okay, I am planning to show some video again. This video do not have an audio. It's just an example of a data mesh. Just see if you can make sense out of what the example is that is getting given in this video. I'll explain it later in a more detailed perspective, but just try to figure out on your own what this following video is giving example about. So what did you saw in this previous video? I really hope that this could be an actually in-person session so that I can hear your voices. But yeah, let me tell you what did you, okay, what should be seen in that video. Okay. So there were data planes, operational data plane and analytical data plane. Data plane. Okay. Data planes, those two data planes means nothing but those analytical data plane is analytical side of it, that are nothing but users, that are consumers, that are data scientists, researchers. And even I didn't mention it, but this data is also really helpful for AI and machine learning. That needless to say, because machine learning and artificial intelligence is all on data. So this is a really important concept that everyone should be aware of. So okay, so analytical data plane is nothing but analytics, and operational data plane is nothing but operation teams who are managing the data. So people like data engineers who are coding in C, C++, Java, Python, any other tools, making this data available to the analytical people. So you might have seen then that there were this loan application thing that was there, credit card and debit card thing that was there. So those things, those data planes needs to interact with each other. Debit card and credit card interaction should be done used for the loan application. Loan application should be made for a car or a housing loan or a computer loan or whatever it is. So all this kind of thing should be interactive with each other, even though they are in itself are manageable. Credit card system in itself is manageable. So if you ever seen your credit card or debit card, you might have seen it may be a MasterCard or a Visa card. So MasterCard is a specific type of, like, it's a specific company who is dealing with all kind of Master and Visa card. The person who is having, or the bank who is issuing that MasterCard is separate. So your SBI may have a MasterCard, okay, but the MasterCard is a separate company, SBI is a separate company, but they are integrating together to get this one product that is a debit card or a credit card, right? So that's what it is, the interaction between them. And you may have also seen that once the operational team interact with each other with all those dotted lines and everything, there were these arrows that were pointing to the analytical data plane, which was nothing but people using those data, people using that analytical data. Okay. So when I correlate this, when I correlate, okay, let's correlate with data warehouse and data lake that we had. What did we had in data warehouse was just one system getting data, business users accessing those data using business objects reports, Spotify reports, Talent, any other Python tool, Python library, Scikit, machine learning, AI, whatever it is. Okay, just one source of truth, one destination. Multiple destination. That's it. Here, multiple places that is available, and multiple people are using it parallelly. That's a interesting stuff for data mesh. It gives that flexibility of multiple things working together. It gives that flexibility. So even though data mesh is a latest is its latest in the market, so I won't say drawback, but one of the challenges in data mesh is, as it is pretty new, companies are still going into in its application or implementation mode. It's it's not yet fully fledged in all the industry. It's not yet fully fledged being adapted overall. It's slowly getting adapted to. So still a lot of potentials of data mesh has to be uncovered, unveiled, and then even more challenges, what problems that can arise with data mesh, or what data mesh cannot handle. As of now, that data is not concrete because the usage is not, we do not have a history of usage. It's just 4 years, right? But still it is proving beneficial in the current world. One of the main challenge, as you can see over here, it's from the complexity, inherent complexity that managing this multiple data products and that dependency across this domain has. So I'll go back to my previous slide just to see. So when I showed this slide, I said that this can be very clumsy, right? So that's what it means. So basically, this connection, right, this interdependency of the domain can be sometime a challenge. Okay, it's an inherent challenge that can the data mesh can face. Multi-domain data duplication. So what does that mean? So domain is separate hexagon boxes. Okay, now we know that there can be a scenario wherein multiple domains may have same kind of data. So suppose a banking user, right? A banking user may have a checking and savings account, and suppose checking domain is separate and savings domain is separate. That won't happen, but just hypothetically. So in that case, users data is getting replicated in both the domains. So my name is getting replicated even in the checkings domain, even in the savings domain. Okay, so that is one of the challenge in database, that the data may get duplicated. Okay, um, federated data governance and quality assurance. So this that is one, as I have explained, that is one of the pillars. Federated data governance is one of the pillar of data mesh, but it also face one of the challenge, because that everything depend on this data governance team. Just because it's all disconnected, like not disconnected, but it's really has to be interconnected, and so everything gets like piled up on data governance team, and different domains may have different data governance in their own account, and they can have a shared commodities, and then resulting deltas might be identified and federated. So that's one of the important stuff. Change management. So what does change management mean? So whenever there is decentralized data management, right, that requires a significant change in management in highly centralized management practices. So whenever there is a highly centralized management practices, they had certain different kind of rules, like data warehouse, data lakes. Those are highly centralized data management practices. And decentralized data management, to adopt a data mesh, it requires a really significant change. Cost and risk. That cost and risk applies to the factor of being a pretty new, as we do not have enough data. So it can be risky, because it's fairly new in the industry. It can be very risky and costly to apply this thing in the real world. And then cross domain analytics. So cross domain analytics, again, is somehow related to multi domains, because this enterprise wide data model, right, it has to be defined to consolidate these various data products and make them available to authorized users in one central location. As of now, it's really an advantage that each data scientist is able to, or each data analyst is able to read the data or utilize the data of that domain. But again, there has to be somewhere this enterprise wide data model also that should be defined in one central location, in order to take an advantage of this central or full enterprise level picture of it. So coming to say that it's not like one is better than other. So basically, data warehouse is better than data lake is better than data mesh. There's nothing such thing. It's all depends on the application. So in today's world as well, if there is a small business, if suppose I am starting a business of manufacture clothing industry, and I want to sell clothes online, and if my business grow, I may not need a data mesh. I may not need a data lake, because I do not have any streaming data, right? I just have an online system wherein I'm selling clothes. I just want to manage the data. Data warehouse would be enough for that. I do not need anything. So it depends all on the use case. Where do we want to use that data? So that's one of the important thing to notice. And each of its application, I have already discussed, but I would like to reiterate. Each of its application is different. Data warehouse may be applicable wherein we do not have like streaming data. We have more kind of structured data. We have to have it in one place. all those features, whatever database or data warehouse pillars are, if my requirement matches that thing, I will go for a data warehouse. If I need more of a streaming data to be handled, I want, okay, I just want data, whatever is available, I want to have it. That's my requirement. And so basically, like Instagram, TikTok, Facebook, right? They want it's all on the social media. Social media is nothing but whatever data they get, they want to utilize it, right? So all this kind of or even Zalando. Okay, Zalando is nothing but it's like an Amazon. Okay, so Zalando is nothing but like an Amazon. So even that, right? So that also needs all streaming data. That data can be stored in a data lake and can be used. Data mesh again depends on the domain based structure. Wherever there is a need for a domain specific thing, which is pretty new, as again that can be used. But so, who are the person behind this change? Just to show the faces so that it's interesting for you guys. So here, this guy is Bill Inmon, who created data warehouse in 1970s. So there's a very famous thing. Ralph Kimball and Bill Inmon. These are the two data warehousing models that are really very what you say, do different approaches to the data warehouse. And depending on the scenarios, people either go with the Bill Inmon method or the Ralph Kimball. You can search it more, or you may have it in your syllabus as well. I'm not sure. Then comes James Dixon. He is from Pentaho, and he's the one who coined the term data lake in 2010. And then there is this lady Zamak Dehgani. You may find a lot of videos from this lady uh, on data mesh, explaining the data mesh, explaining what can. She also explained what can, how, when should a enterprise go for a data mesh or not. Okay, so that's what we have. To summarize what we went over today, okay, we went over database and data architecture. I hope you are clear now what data architecture really is. uh, to reiterate, it's a set of rules, models, and policies that we build in order to build a good data. I want to reiterate that because now we have went through our data warehouse, data lake, and data mesh. So now you should better understand what as architecture means. It's a way of arranging data in different ways, handling data in a different way, so that the foundation of whatever you're building is strong. Okay. Then we went to data warehouse. Data warehouse is nothing but a centralized location, one source of truth and batch processing system, wherein we get all the data from the sources, and then ETL model is available, that is extract, transform, and load, and then BI analytics is applied on that. Okay. Pillars of the data warehouse are nothing but subject oriented. Summarize is one of the important pillar. Time variant, it should, and then it's non-volatile, and data is integrated. So those are some of the pillars of data warehouse. And business implementation, I shared with you on banking domain. I didn't share with you on insurance domain, but I did share with you on banking domain how ETL and BI can be leveraged in banking domain. So just one additional information for you over here. When we have, okay, so this is an if you can remember this for your like for your coming future, it will be really good. Data are also called as data can be known as factual data or dimensional data. Okay, so factual data is nothing but which shows fact about a data. Okay, so for example, it shows numbers. For example, in stock market, right? In stock, I bought a share of $100. So $100 becomes a factual data that Sheetal Kedia, this person bought a share of $100. So that's a factual data. That is $100 is a fact information. It's a fact that okay, Sheetal Kedia bought this thing. Okay. Um, then aggregated, as I already explained, aggregated is nothing but aggregating those factual information. All these $100 or whatever I bought over the time, those will be aggregated to show what I bought over past 10 years, if that is the report. So that's one of the important term: factual, fact data, factual thing, dimensional thing. Okay. And then we went over challenges based. Then we have and then we have data mesh. So to connect the dots with the data lake, the problems that were in data warehouse, that is non-processing of unstructured data, technical depths and everything. Some of them were addressed by data lake, that it was able to process the structured, semi-structured, and structured data with lots of volumes of data, like lots of size, like a bigger size. It doesn't matter. So those were overcome with the data lake. So definition of data lake is nothing but an easier way to understand is ingest the data, um, transform the data, then analyze the data. Okay. And then the challenges that we faced was it specialized skills may be required to handle this data lake, and then it may turn into data swarms. Data swarms is nothing but just accumulating data and just going on accumulating data, and we even don't know whether we are accumulating a good thing or a bad thing. We are just accumulating. That those can be some of the challenges in data lake. And that comes then comes in data mesh, which is the final version of the final stage of our third generation, of the latest coin term or latest architected term. So if we connect the dots between data lake and data mesh, data lake was centralized and data mesh is decentralized. So the one of the problem of data lake that was having this data swarms, that is getting the data. Some to some extent we can get overcome that using data mesh, just because when we have these separate domains, those domain people know what they want. If I'm from an administrative guy, I know what do I want. I know what data is logical for me. I may not get the online streaming data because that is illogical to me. Administrative people want administration related data. That is all user related data. So it helps control what data I have. Then a definition of we went over definition of data mesh and pillar, and then some of the challenges that were faced from data mesh. And those were nothing but having cost and risk, having domain oriented, having federated data governance, having multiple domain data application. One of the notes that I would like to make, whoever is attending as a student, it's really important that you have your basics clear from your college studies. That's really important. Like for example, if you have database management system or whatever related to that, it's really important that you have all that clear, because any such technologies that will be coming henceforth in future, tomorrow something else may come, right? Today's data mesh, tomorrow something else may come. The basic foundation is the same. It's all permutation and combination of that basic thing. Sometimes that acid properties are applied, sometimes acid properties are not applied. So it's one or the other. So have your basic. I cannot stress enough on importance of having the basics clear. So that would be it. And yeah, so I yeah, during the start of this presentation, I asked that I will have a small challenge. It's a kind of a fun. So I would like to know if you can tell me how many times I may have used the word data in this talk. This is just to stress the importance of the data in today's world. It's a biz. Data is a biz. Actually, I can tell you that it's growing. It's ever growing, and it's really important to manage, because it keeps getting complicated, and it's really important to have data. And getting information out of the data is really important. I cannot stress that enough. Um, I think I will close my talk with this. Thank you all for attending. You can follow me on LinkedIn. I'm also in GitHub, and I'm a proud ex-student of Patkar College. So, yeah, thanks for your attention. I hope that you might have gained some knowledge from this session, at least to some extent. But there is a lot of opportunity out there for data, like from data perspective. So, yeah, your future is in good hands. Thank you. So one more thing I just want to say, if anyone has any questions, please feel through comment, and I'm happy to answer.
Thank you very much, Ms. Kedia, for the information and knowledge you've shared with us on data architecture, data warehouse, lake, and mesh, and all of its business implementations. It was really wonderful. Uh, well, the last question that you asked is one of the most essential things in today's era, data. And I approximately think you use the word data somewhere around 15 or 16 times. And I think the audience is also saying that a lot of times data as the word was taken up. It's very important for us to understand the transformations, because unless we are not evolving from the traditional system, we will never end up getting advanced. So thank you very much for giving us this ideology of how transformation has taken over time from data warehouse to lake and to data mesh.
Sure, sure.
Actually, I do have a few questions on my personal opinion, and I might want to ask those questions. But before I drop my personal questions, I would request the audience and the participants, if in case you have any questions, please feel free to drop the questions in the chat. We are ready to take your questions now. Okay, so Ms. Kedia, we have one question here from Ms. Pooja Aman, and the question is how to decide when should we have a data mesh?
Okay. Um, Few important points to decide on data mesh. One of the important point: do you want a centralized or decentralized data? Is your data, whatever your enterprise level, wherever you are working, okay, is it so complicated that having a centralized data would be a pain point? If not, no need of data mesh, right? If yes, that handling and managing those different kinds of data at one go at one place, it's difficult to manage, then you should surely go for a data mesh. I would say that is a really important point. However, there are other factors as well, but I would say that it's one of the important point. So I
Okay,
hope I answered her question.
yeah. Okay, thank you very much. So, dear participants, if you have any questions, please drop in. We are ready to take the questions from you now. Okay. Meanwhile, we have the questions from the audience. I would like to ask a question on my personal opinion, Miss Kedia. So, what I was thinking about is today we have cloud computing and big data, both of it at their best. And there's this thing always that we have, that we always want to have a very analytically oriented approach, and we always try to apply this because we want to get solutions to all the problems that we are actually either existing, the problems that we actually have in the business or in the organization or whatever that is as a matter of fact, or the problems that we might face in the future. And saying that the data we have today is really big and it's really huge, storage centers, generally data centers, are not the best option there, and they will not turn out to be very efficient. And because I said cloud computing is at its best, do we have any cloud computing or cloud based data warehouse that would be preferred over a general or a traditional data warehouse?
Yeah, we do have. So yeah, there are a lot of options available out there in the market. In the like, since the cloud is developed, so now we all know there are three cloud leaders, right? Amazon, Google, and Microsoft Azure. Each one of them do offer their data warehouse, data lake facilities. So they own their own data lakes, and even not this three bigger players, even like Informatica. I told, right, I was using Informatica as a tool. Informatica in itself has its own like cloud related data warehouse tools, and there are Snowflake. There are a lot many out there which you can use for data warehouse and even in data lakes.
Okay, thank you very much. We have a question from the audience, from Sameep calmly. And the question is, what are the tools useful for data analysis?
Okay, so data analysis is like, okay, so just let me explain for everyone's idea, okay, what is data analysis. So when we try to make sure that the data that we are trying to have, it can be used somehow. Okay, it can be analyzed for a better results. That's when data analysis come into picture. Okay, so most basic tool that we can use is data is an Excel. Microsoft Excel is also a tool that can be used for data analysis. That's a very basic, but we do not go for basic. We want an optimized and efficient solution. In today's world, Python is one of the really good data analysis tool. R is really good. SAS is really good. W, Power BI, Apache Spark. These are really good data analysis tool that can be used. There are a lot of libraries out there which are open source and that are really like those are data analytical tools. Yeah.
Yeah, one of the most basic ones, as you said, is Excel. So that is very friendly. At the same time, the one that is very widely used. So even if a person is non coming from a non-technical background and still wants to perform data analysis, even in my personal opinion, Microsoft's Excel is the best alternative that one can ever have.
Yeah, at least as per the student's perspective, as they may not be having hands-on and everything. If they just want to start with data analysis, they can start with an Excel, even if they do not know Python. At least they can know the basics or what is data analysis using the Excel itself.
Correct, correct, correct. I have another question in mind. So lately, I've just come to know that there are lots of different modern data warehouses,
Mhm.
and they are very different from the traditional data warehouses because the most important concern that they have is they are focused on storing multi-structured data, and they are more concerned with having data that is in different forms. I just wanted to know how efficient is a modern data warehouse, and why exactly was there a need for bringing in modern data warehouse?
Actually, that's an interesting thing. Actually, I was planning to include the modern data warehouse thing also in my slide, but then I refrained because I thought let me stick to the basics. But yeah, that's a really good thing. Modern data warehouse do solve lot of not lot of, but it does solve many challenges that is faced by the older version of data warehouse. And so, for example, in the modern data warehouse, you can use Hadoop in between. So, modern data warehouse architecture, if I can share my screen, I can show you what I have.
Sure, ma'am.
But yeah, let me show what do I have in my screen. Okay, just give me a moment. Okay, uh, okay. Let me share just a window. Sorry for that. Yeah, can you see my screen?
No, no, Miss Kedia, it's not
Okay, it's not
visible. Yeah,
visible
now
yet.
it is visible. It's visible
Okay.
now. Yeah.
Okay, fine. So this is what I wanted to present in today's video, in today's thing, but I refrained because I thought it would be too much for them, for everyone. So as you can see, the layers over here that is getting added is Hadoop, right? So this layer was not added in the actual data warehouse. So what does this tells us, right? So Hadoop I introduced in data lake because in data lake there was a lot of big data, and we wanted this Hadoop thing to be used when there was a complex data. So this modern data warehouse architecture tries to overcome that scalability issue using this added layer, basically having this OLTP database load the data into Hadoop that it can manage all this like unstructured big data efficiently and external data, and then it goes into staging area. So that's how modern data warehouse architecture tries to overcome one or two of like two challenges where scalability issue and dealing with unstructured data. So that can be handled using just one introduced layer.
Okay, yeah. Thank you, ma'am, for addressing that question. Uh, there's one more thing that's there in my mind, which is that again I have come to know this lately that data lakes they are generally more focused on use cases that come from a very data science background.
Yes, that's right.
And data warehouse, on the contrary, focuses on enterprise oriented analytics.
That's right.
So I just wanted to know that in an enterprise, which components or which factors are present, or what things are considered while a data warehouse is prepared.
Within an enterprise, okay, that's an interesting question. So there are a lot of stuff. First of all, is the source systems. Okay, what are my source systems? From where are we? From where am I reading the data? So that's one of the important place. That is one of the important thing to understand, to while developing an enterprise data warehouse. Another important is how the data will be used, how frequently the data will be used, and the data scientist or whoever is going to use my data, what level of data that they want. Is it an aggregated form? It's in factual form? What kind of data that they want? It's one of the another deciding factor. um, and there are multi more actually, but out of top of my head, that's what I can remember. But there are multi more factors that are involved for this, like, to deciding on enterprise wide data warehouse architecture. One of the important step I would say is building some entity relationship models. So while constructing this data warehouse, the very first step is to actually have this entity relationship model that we build and then that we present to the entire I would say the design architect people. Then we understand with them, okay, what we show in that model enterprise diagram or enterprise relationship model is we show how this tables, what tables are we planning to create, how this will be interconnected, and what kind of data they will hold. That gives the users or the whoever the decision makers are an insight on how the data warehouse will look like. And based on that, they will say, okay, yeah, I'm okay with this, and you can go ahead and, like, yeah. So that's how we go ahead.
Which means even when you're dealing with such an important data warehouse, it's very important to consider the basic techniques and tactics that are coming from software engineering.
Really, that's why in the last very point I mentioned, it's really important for students out here, whoever is listening, that concentrate on the basics. If you have your basics covered, I think you can manage going forward other stuffs too.
Also, I would just want to bring this point again. You highlighted somewhere in your talk that there's something called a self-served infrastructure, and today's age is often called as a self-service based business intelligence age. So again, I wanted to know here that in a business intelligence architecture, there are lots of different processes. So there are lots of external data warehouses. There is a great deal of ETL tool that takes place. There is a lot of knowledge management that goes in hand. Then we also have lots of decision makers coming into picture, etc., etc. I just wanted to know which among the entire BI system, if I were to say state it this way, if there is a great amount of business intelligence system that is put up in front of somebody, which of the processes would generally be given a self-served approach rather than the other one, stating that today's era is a more self-service business intelligence era.
Yeah. Mm, I still believe it would be an infrastructure. That's my personal take, actually. That's it depends on each and every individual, but I still believe, coming from this data background and doing this data thing since last 11 years, I believe infrastructure is a big pain point in our area, in database, or basically anything. Whenever we deal with data, when we have a separate infrastructure team, okay, and when there is any issue with any infrastructure it's not available or anything, it takes a lot of lag time to go and to and fro with that team, infrastructure team. So if we have a self-serve in data infrastructure as a platform, that will actually greatly reduce the what you say dependency of the other team, and it will really, like, be helpful to make sure that whatever we are having is perfect, it's correct, without relying on other people.
Correct. So often stating that what you just said right now, often it is said that data mesh, because the data mesh is the one that is very new, the one which is very fresh, like something that
Yes.
came around 2018 or so. It is
Yeah.
often sometimes called as a data platform version of microservices. So they generally highlight it by stating that it is more of a microservices because we've come down from
Yeah.
monoliths to microservices. So it is considered that the evolution of data storage, starting from data warehouse, we are now at data mesh. So data
Yeah.
mesh is just a microservice which is to a monolith system. I I
Yeah,
think.
yeah, yeah, yeah. Yeah, I would totally agree
Right.
to that. Yeah. So yeah,
Uh,
I would totally agree to that because microservices, if you see, okay, if, who may not know in this entire group, microservices are nothing but handling like what I explained in data mesh, handling all these small domains separately. Microservices are also doing the same thing for an entire application. So when I say administrative, that I gave two example, administrative and marketing, right? So marketing may have its front end, its back end, its entire stuff, right? So dealing this entire stuff itself, it's a microservices, and dealing the database separately, it's a sub part of that microservices. So yeah, it's very relatable, it's really relatable to the microservices.
Thank you very much. I had a lot of questions in mind, and you've answered all of them. Thank you so much. And on behalf of all the participants, also who have attended and who are listening to me, I guess they've also had a nice exposure to the questions that you addressed, the questions that came up from the audience, that questions that came up from the personal opinions, and a nice talk at the end. I really liked that. Thank you very much, Ms. Sheetal Kedia, for addressing each of the questions that were put in forward. I would like to thank you once again for the knowledge you've shared with us. It's really going to be very very helpful, and it's something that's very important for all of us to understand at the very same time. So I really appreciate that. Thank you very much once again.
Yeah,
Uh,
thanks for having me, and I'm glad to share this knowledge. And I hope if some of the students can get some information out of my 1 hour talk, I'll be really grateful.
Thank you so much. Okay, so dear participants and the entire audience, everyone listening to us, let's now move on to phase two. And for this, I may now request my co-host, Miss Manali Patil, to take over.
Yeah, thank you very much, Miss Riva. Once again, good morning to the Honorable Speaker, respected in charge Principal Ma'am, Chief Coordinator Ma'am, teachers, and all the participants from around the globe. I, Ms. Manali Patil, faculty at the Department of Computer Science, would like to introduce you all to our next speaker, who is India's most 20th influential conversational AI leader and the Director of Decision Science, Mr. Bastian Robin. Mr. Robin is a chief data scientist at the Clever Insight, working on the areas such as the recommendation system, spam filtering, user modeling, fraud detection, social graph mining, etc. Sir has also worked as a director of data science and artificial intelligence, and also he has been head of a data science and AI. Mr. Robin holds more than 9 plus years of experience in the field. I would now like to request Sir to take over the session and dive us deeper into the concept of data driven decision science. Over to you, sir.
Uh, am I audible? Am I audible? Hello, Manali, am I audible? Hello.
Sir is asking if he's audible.
Y- yes, sir, you're audible.
Okay, thank you. Thank you for that brief introduction. And I once again need to thank everyone for giving this opportunity to be a part of this interesting session. So I was just joining at the last of the discussion in the previous session, and um, the way it was going was pretty much interesting. So let's make it a little different. My way of approaching this session would be like, let's make it more interactive, and I'll be keeping my comment box open, but I'll be happy to take comments in the middle, not I mean, like somewhere I'll stop or put a pause and take the comments from there. And if you are very keen and very eager to know a couple of things from an industry point of view, like I would say, like take the comments at the last so that I'll have enough time to answer everyone. Fine. So let me start my screen sharing. Can anyone confirm me whether my screens are visible? Hello? Whether my screen is visible? Can anyone give me a confirmation?
Yes, sir. Yes, sir.
Okay,
Your
cool.
screen is
Sounds good.
visible.
Perfect. Perfect. Fine. So today's talk is going to be mainly on something called data-driven decision science, and even you can call it as A to Z of data science. See, since morning you're listening into different aspects about data from a point of a data engineering pipeline point of view, but I'm coming to a different point of view. That is like, okay, if you have data, what is next, right? Because we know that like since years we have data, we are collecting different set of data. We start keeping all this data in archives, keep it like a bank or a telecom or any different companies. There is abundant data which is stored in archives that is only kept for the purpose of reference. For example, whenever you want to cross validate, okay, what was the transaction detail, you just go and check the archives to get the data. That was how it was happening. But last 10 years time frame, you can see a significant change in the way what data has like come across. So when I start working on data science, there was no field called data science that time. There was no name called data scientist. That keyword itself was not there. Later it was born, and now you randomly go and pick anyone from the market. I mean, like any student or anyone who's a technical person, you ask them what you really want to become. The first thing they'll say is, I want to become a data scientist. That's very normal, and it's very much clear that anyone, everyone want to become a data scientist because it's a high paying job, it's very interesting job, etc. But we have to see things from a granular point of view. That is, okay, what really makes someone a good data scientist? Okay, now there are a lot of courses online which are telling that, okay, you take this course, you'll become a data scientist, you take this course, you'll become a data scientist or a data machine learning engineer, etc. and all. Now, if someone can learn a course that much easily, then why can data science being very hot and high in demand and they're well paid? If everyone can take the course and learn it, how can we can see like everyone in the world will be a data scientist because that's a high paying job. The reality is different. As an industry point of view, the whatever you see outside, it's full of noise. It's not reality. The reality is totally different. You can really become a good data scientist and earn well, and you will have a wonderful opportunity if you study in the right way. So in data science, there is nothing called right way or wrong way, but the thing is like what you practice, that should be like, you have to be a person of patience, and you should have practiced lot of data problems. That doesn't mean directly going to Kaggle and solving some problems and becoming a data machine learning engineer, because data science is a subject of s- solving problems. Okay, you can work on data pipelines, you can take big data, Hadoop, and all these things is fine. If you do all these things, you are called as a data engineer, not data scientist, because it's purely a software engineering job. You build anything, whatever you build, end of the day, it's software engineering. But what differentiate that from a data scientist? That's what today's talk is going to be focused on. Let me give you a very small challenge, and I can just tell you this. You can put your comments on the chat box, and the challenge is pretty simple. That's 3 questions I'll be giving. Each question takes 10 seconds, so 30 seconds for 3 questions. And exactly after 10 seconds, I'll keep on changing the slides. Okay, and I would love to see the answers in the chat box. Okay, so your challenge starts now. How many numbers are above 100? You can post on the chat box. How many numbers are below 10? Which quadrant has the highest total? Out of this given 4 quadrants, which has the highest total? Now let me come to the chat box and see. Okay, I can see few people answering, few people didn't. But definitely I could have, I'm 100% sure not even one person could have given a correct answer for all the 3 questions. Okay, only one person gave the right answer, that is the 4th quadrant. Now, what's the deal here? That is, I'm giving you 10 seconds on a very small matrix of numbers. And then I'm asking you like to find numbers which are above 100, numbers which are below 10, and which quadrant has the highest total. 30 seconds I've given. You got some number. Everyone got different. Some will be saying, okay, there are 7 numbers, there are 6 numbers, 4 numbers. It will be varying across. But you're not sure whether it is correct or not. Now the same questions, if I'm asking you with few visual clues, same 30 seconds if I'm giving, now I think most of you will be able to answer the question. Let's start it again. How many numbers are above 100? How many numbers are below 10? Which quadrant has the highest total? Okay. Now let me see if anyone has answered. Uh, Interesting. I can see a lot of people answering. It's really a good thing. See, what happened here is like you can see everyone gave a correct answer for the first one, second one, and as well for the 4th one. What happens here? The simple reality is in business, time is equal to money. That means if I'm giving you 30 seconds, first time I gave you 30 seconds, none of them were able to correctly tell what is the answer. But when I just gave you with little visual clues, what happened is ultimately you were able to give the correct answer and 99% correct answer. And the interesting thing is out of 10 seconds for each question, within first 3 seconds itself, most of people find the answer. So 10 minus 3, 7. Per question you are saving 7 seconds. That means in business world, you are going to see a lot of data. That is, there is no change in that. You are going to see tremendous amount of data which is generated. But most of people talk from the point of data engineering, getting the data. But you can see out of this entire 100% market of data practitioners, 70 to 80% of people focus on building the pipelines, fetching the data, but only 20% of people really work on the data to find interesting insights out of it. This is hard reality. This is the reason most of people who complete data science courses and everything, lot of practices, everything, they come into that 80% zone, but actually you have to be in this 20% zone. Companies look for data practitioners who can find interesting stories from the data. You should be able to analyze the data. You should be able to build insights, not technically speaking, directly building machine learning models, deep learning models. No, because to build a model, you have 10 to 15 lines of code which you can copy and paste and run a model. Pretty easy. The interesting, most important and interesting aspect of this data science is you may build a model, but you need a expert to interpret your model, and that model interpretation is very much lagging among everyone. This is the reason when you study all these things, still you don't get a job. If you even if you get a job, surviving there is very tough. So how to make yourself very much data rich? That is, this is an interesting quote which I always say: data will talk to you if you are willing to listen. Like in the previous starting of the session, Riva ma'am was telling, right? Data will talk to you if you're willing to listen. Now, what is a big deal in it? Simple thing. What happens is, what sir wants to tell this. Data will talk to you if you're willing to listen. See, this we have in our office and a very big chart. We put it there. This quote is very powerful quote. I'll tell you why. See, whenever you start working on real data, I'm telling about real data, not the toy data set. The real data, it's like wildlife. You go for wildlife and you see every single data, which is nothing is formalized or nothing is standardized. It is really wild. We can easily get confused. We can easily get diverted. We can easily get dropped out of that particular interest itself. The reason is very simple. That's data science requires you to be a very patient person. How many of them like Sherlock Holmes? How many of them have watched Sherlock Holmes movies? How many of them have watched Sherlock Holmes movies? No one? I can't see any comments. Okay, fine. I think most of people could have watched Sherlock Holmes movies. It's very clearly seen whenever Sherlock Holmes is solving a case, first thing what he does is he goes to the place where the incident occurred and he start gathering every single clue from that particular point. I mean, like everything, without any assumption. He start collecting different clues, bring it to his place, put everything on his table, and start mapping one to everything together. And that's what he called as connecting the dots. When you connect all the clues together, new assumptions are formed. From that assumption, the case starts. This is exactly the job of a data scientist. So even you can say a data science job is like a private detective, someone who is going to do all his investigation on data, not just some tool is already there where you take and put a data, it will give you an outcome. No, it will give you an outcome, but you will not be able to understand what makes that outcome, what relates to that outcome. How can I make it in the business term that this outcome? How can I interpret that outcome? Now, in that is the real fulcrum of data science. So whenever your data is being correctly processed and correctly asked, I mean, like you should ask the right kind of questions to the data, then your data will confess. So that's why I'm telling you, data will talk to you only if you're willing to listen. You cannot randomly go and ask some insights from the data. You should ask the right question first. That question, your data should be able to answer. Then only you build insights, stories, narratives from there. Now, this is a common thing which comes to everyone now. Like, how can data benefit me? Which tool should I use for data science? Generally, this is a common question which every time anyone asks. How data science can benefit me, or what kind of data I should take, or which tool should I master to use data science? In those kind of situation, my only answer is tools are everything. Tools are important, but technique is everything in data science. Why I say that? See, my mentor, he always used to say that, Robin, someone who can really master in spreadsheets, who can use spreadsheets 100%, like MS Excel or any other spreadsheet tools, or Google Sheets also, you can say. Someone who can master spreadsheets, they can be called as a good data analyst. It doesn't need you to be rich in Python, to be mastered in programming or anything else. Yeah, slightly programming knowledge is important whenever you want to process data, that you can get it done by someone else. You are an analyst. You should be able to find insight from the data. That's what is more important there. Now, if you really want to master, just start with Excel, because there is no other way where you can master in data science other than Excel first, second SQL. Then you can go for advanced like R, Python, and everything. But those things does the same thing what Excel does, but only difference is they do it on a little bigger scale. That means bigger size data. That's it. But first and foremost thing, as an analyst, you should know what to analyze, and how to create a story out of it. So let me take you a very small example, which I consider to be one of the most Important thing which you people need to know. So for this particular example, I'm taking a healthcare use case. You know healthcare, right? So generally, if you understand this four pillars of complete analytics, you will easily able to do data science experiments in upcoming days. Fine. Now consider you are a patient. You have some illness. You're going to a doctor. When you go to a doctor, first thing what doctor asks is, what are your symptoms? What is happening to you? Since when? What? What was your last blood sugar level report? Show me. Right. Doctors start collecting all information about your past. Okay. All single data points about your past. That phase is called descriptive phase. That is knowing about your data's past data. Now, after that, the doctor says, okay, fine, let's do something. Let's check how is your blood sugar level or how is the scan report coming today in real time, present. Okay. So the doctor will give you a couple of tests. You should finish it and come, and she will check that report. That phase is called diagnostic phase. That means knowing about your data present. Now, the doctor has known about your past. Doctor is knowing about your present. Now, finally, the doctor predicts what will happen to you based out on your past and present data. That is, she just consider, okay, last week your BP sugar level was this much. Today, I can see significantly it is really hiked up in the diagnostic phase. That means you have an upward trend in your variations in your BP and sugar level. So definitely there is 90% chance are there. If I'm not treating you, tomorrow you may become very sick because your vitals are shooting up pretty much higher in a faster rate. Doctor is able to predict your future using past and present data, and that phase we call it as predictive phase. Now 90% of people who wants to become a data scientist or data analyst, they believe that prediction is the ultimate, right? Prediction is the ultimate, so that if I'm able to predict something, I can solve something. Maybe not completely. Predicting and knowing what will happen is good, but the doctor knowing what will happen to you tomorrow will never going to change you, right? But when you get cured, when the doctor is able to give you a prescription, if doctor is coming and telling you, hey, tomorrow your blood level and sugar level will be this much, have you seen any point of time doctor writing that what will be your tomorrow's blood and sugar level? No. But the doctor prescribes medicines that take this medicine morning and evening. You follow that prescription, you get cured. So that phase is called prescriptive phase. That means ability to convert all your analytical insights into actionable. That phase is called as prescriptive phase. In order to prescribe a medicine, he should be a domain expert. Now it very clearly shows that all the three first phases anyone can do, any generalist can do, but prescribing a right medicine only a doctor can do. That is why in data science is not about tool oriented subject, it's about domain oriented person subject. Domain is, banking and finance and insurance industry, telecom, supply chain, logistic, education, food industry, transportation industry, and healthcare, pharma. All these are domains. Okay. So if you really want to become a good data analyst or a data scientist, from the day one when you want to become that, pick one domain. That means healthcare, pharma, telecom, banking and finance, manufacturing, logistics, supply chain. Like that, pick any one domain. Understand the domain very well, how business happens in that domain. Very thoroughly, you need to understand. And you start using analytics as a skill set. Got my point? That is, in a simple terms, what I can say is, when you become a domain person, that's the reason most of the time when you see uh, people who come directly from engineering background are not really shining in data science, but people who have already worked in some companies as a manager or someone specific role, when they add data analytics as a skill set, they become really good in their profile. Success is very high for them because they know the domain very well. They are not directly going and beating around the bush. They know exactly what problem is and what is the data available, then what I need to do. That's what is important. From the day one, pick a domain. That is, you cannot become a general data scientist. You have to be mastered in any one area. Then you have to practice on that data, because data in one field will be represented as different in another field. Okay. Data represented in healthcare will not be the same thing which is represented in manufacturing or BFSI industry. It will be different. So be a domain rich person and be a domain expertise. Then add data analytics as a skill set. That saves you a lot of time. So in Enlarge, I want to tell you, learn to love the data, because the real hero is data. Now let me take you to a very interesting example. There is an online psychological, online psychometric test called Myers-Briggs Type Indicator Test. Okay, if you visit the website called projects.5038.com/personality quiz, this is the URL you can see in the below. I'll share the URL at the end of the session if you want. If you visit this URL, they give you with 30 questions. Okay, 30 different questions. Each question will be having different, you can see this is a sample question. For example, I tend to be quiet. How much I agree, how much I disagree, how much neutral I am. Like that, 5 scales are given. Out of 5 scale, you have to pick any one scale. You can say that I tend to be quiet. Agree a little. I tend to be quiet. No, I can strongly agree I'm a quiet person. Like that, 30 questions are given and 30 answers, you get it. Okay. Now, each question has something interesting to do. You can see this neutral is 0. Anything rightmost is positive. Anything leftmost is negative. Now, let's take this data as an outcome in the form of report card. You can see openness to experience, 79 out of 100. Agreeableness, 75 out of 100. Consciousness, 42 out of 100. Negative emotionality, 50 out of 50. Extraversion, 58. Now, these are the numbers score which you got for each question you attended, which very clearly shows you what kind of personality you are. Interesting. Now, I'm taking that 30 questions. For example, Jack is a person who attended 30 questions. Each 30, each question has some score, 38, 40, 50, like that. Some score is given out of 0 to 100. Now, for example, Jack, for the first question, he got 38. I'm putting it on a range scale like 0 to 100. If it is 0, he is an introvert. If it is 100, he is an extrovert. In the middle, he will be an ambivert. Now, whenever we are handling data like this, rather than using the general number system, let's convert this number into vectors, scalars and vectors. That means rather than putting 0 to 100, let me put it like 0 to 1, 0 to -1. That means this is a scale which will be typically correct. Now, 0 is nothing but neutral. 1 is an other end of it, and a negative is coming like that. This is a correct range we have to be. Now, for example, in the previous one, you can see 38. This 38, when you are bringing in under the scale of 0 to 1, you will get -0.4, because it's below 50, right? It's below 50, which is coming exactly in this point. So this is the rank. Now, I can calculate, I just check all the other 30 questions, whatever Jack has attended, and rank it like this. Now, what happens is, the moment when we are bringing it under 0 to 1, we are talking something called graph. We are talking in the terms of graphs. For example, Jack has attended 5 questions. That 5 questions, this is the mark which he got, scores which he got. Another person also attended the same question. He is getting a rank like this. Third person also attended the same quest, and his personality answers are different. Now, you can see, as these are nothing but, you can plot it on a graph. So Jack, you can see he has a projection over here. Person 1 has a projection over here. Person 2 is having a projection over here. Now, can anyone tell me, I'm asking you a question, who out of given 3 person, given 2 person, which person is similar to Jack? He has similar personality like Jack. Most of people will be thinking, okay, Jack is having -0.4 and person 2 is -0.5. So most of the thing, the numbers whatever represented here clearly shows that Jack and person 2 may be similar, but not the reality. You should not compare number to number to number. You have to see the similarities. When you really see who is similar to it, person 1 is similar, because you can see they both are in the same coordinates. Interesting. Now, what if I'm asking a question, if there is a function called similarity, and in that function if I can pass two vectors like Jack and person 1, or person 2 and Jack, like that, if I'm able to pass two vectors, it is able to calculate a score for me and give it. That means how much similar they are. For example, if I'm giving person Jack and person 1, it should give okay, 30% similar. If I put Jack and person 2, okay, 80% similar. Like that, if it this method, this function is able to return back, that's more interesting. So to do that, is there any function available in math? Yes, it does. When you have gone through your basic calculus or linear algebra, you could have studied about a function called cosine similarity, right? Cosine similarity is a function which is used to compare two vectors and give you a score of how much similar two functions are. So in simple terms, this is what we get it. The cosine similarity function takes two vectors and it gives back the similarity score for it. For example, person Jack with person 1 was 87% similar. Jack with person 2 minus 0.20% similar. So it clearly shows that I'm able to find two vector similarity. What is the purpose of it? Where can I use it? Can anyone tell me where can I use it? I'm taking Jack, person 1, person 2, and I'm taking all their traits, each behavior, each psychological factors about them, and comparing them, and I'm able to find a similarity of them. I can easily find who is similar to Jack using this code. Excuse me. You can see here person 1 got 86 percentage, person 2 got 0.5 percentage, and person 3 is least not similar. If I'm able to identify who is similar, where can I use this function? What are the other use cases I can use it? Simple examples are, have you seen Netflix, Flipkart, Amazon, or any kind of e-commerce? When you buy one product, within few minutes you can find all similar product listed there. How many of them have seen that? I'm looking for a comment. How many of them have seen that whenever you buy any product, ultimately we can see there are similar products being recommended? Or when you watch a YouTube video, the similar type of videos are visible. How many of them have seen? I'm checking the chat box. And don't you think we have taken Jack, person 1, person 2 as real people? If if the same thing I'm doing on products, right? If I'm exactly taking each and every single item as products and their features, I'm quantifying it, and I can compare it create a score. For example, 30 products I'm taking with one product. All 30 products I'm calculating cosine similarity and sort that outcome. Pick the top 5 product, push it. Don't you feel that is the early stage of a recommendation system? That is the power of using the techniques. This is why I always say we really forget something. That is, we forget the techniques and we are jumping for tools. Tools are important, but technique is everything. A very basic formula which we have studied in mathematics called cosine similarity is doing this much powerful thing. A very simple formula which you can easily learn. Right? Like that, lot of formulas are there. Cosine similarity is a formula to calculate the distance between two different projections inside a graph, specifically like an Euclidean distance, Manhattan distance. There are multiple distance calculation formulas like Markovian chains, and Euclidean, and like this. If you are able to understand this formula better, you can do you can do a significant work on data science and build interesting algorithms around it. That's why I'm telling you, first understand how the internals works. Now let's get inside. See, in the entire world, generally, whenever we have any questions to ask, we generally go to Google and search for that word. Immediately, you can see it is landing on a Wikipedia page. And once you go inside a Wikipedia page, there will be a lot of links on that page. If you click on any page, you will never go outside Wikipedia. You will be rotating inside Wikipedia itself. That much bigger Wikipedia is. So what has done is a group of researchers, they have taken all the words inside Wikipedia. Words, okay? The and is every word inside Wikipedia. And there is another collection called gigawords. There are a lot of words are there. They took all these words and they manually created an algorithm to create a vector for them. That means if you take a word called king, for that word called king, they created a set of characteristics. Each, close to, 50 dimensions will be there. You can be 50 different aspects about that word. They have put. Now, this is the representation of king. So, in general, mathematically speaking, if you want to get the word called king, this is the vector. This number is a vector. For a king, this is the vector. There are 50 characteristics they have calculated. Based out on some concept, they have created 50 different features, triads. You can call each of them as one on triad, like all that 30 questions you attended, right? Like that, 50 information about the word called king. Now, they have done it for close to 4 lakh vectors they have created. Got my point? So let's get into next level. I took that simple vector and I plotted a graph like this. Close to 50 cells you can see, and the number is being put inside this. Okay, you can see nothing interesting happening. Now I'm introducing something interesting there by adding a color range. That means if the value is between 0 to 8, this is the color. Minus 8.8 to 1.6, this is the color range. Same way, 0 to minus 0.8, this is the color range. Minus 0.8 to minus 1.6, this is the color range. Now you can see I got a pattern for the name. Just a simple word called king, there is a pattern generated. Now I'm doing the same for king, man, woman. Take 3 words and I'm going to the trained model. I'm getting the vector for each word. For king, I already got the vector. For man, I got another vector. For woman, I got another vector. You can see some interesting pattern among them. That is, king, man, and woman have something common. All of them has this particular feature number, maybe some 38 or 8. Out of 50, it may be some 38 or something will be there. They are similar. Here you can say king is having something very strong, where man and woman has less. Man and woman has some feature which king doesn't has. King has something very unique which man and woman doesn't have. Maybe it may be representing they are very rich, or this may be representing that they may be a human. This may be representing like other aspects. Man and woman, yes, they are having something which king has very less. So you can start seeing a lot of analogies inside this when you really see. But the interesting thing comes when you go next level. That is, I'm taking even more words like queen, woman, girl, boy, man, king, queen, water. All the words, and I'm plotting a color chart for it. All of them have something similar. Maybe this particular feature is representing about they're a part of earth. Women and girl has something very common, and boy and men has the same thing, but the color is not this much darker. Value is very less, but they have very strong values. Same way, queen is having something stronger, where king is having something lighter. Women and men has something very stronger. So water, you can see only all other things have dark blue, and water has very less number. So This is the pattern which comes. When you really look into it, there are a lot of interesting pattern come, but the most interesting thing is not this. That is, let's enter into the analogies. I am doing a very simple arithmetic operation on that vectors. I take king vector and I remove man from that king vector and I add a woman into that vector. Now I want your answer. If I take a king and remove the man from that king and add a woman into that king, what will be the answer? I'm looking for the answer. King minus man plus women. I'm looking in the comment section for your answers. What can be the answer? What is the next predicted word? Perfect. Vikas has given a correct word, that is, let's see. You can see king minus man plus a woman is equal to queen. You can see the model which gives the outcome very closer related word is queen. Now it's getting more interesting because how can words give the similarities and how it's able to correctly give what is next? You can see after that next is thorn. When you take a king, remove the man, you have the thorn. The throne is there. Add the women to the throne, then it's queen. That's what the next word is queen. Immediately after queen, the next probable word is throne. Okay, let's see from this aspect. You can see king minus man plus woman is queen. You can see I take a king and a man. If I'm taking this and I'm deleting man from that, I get like this. And when I'm adding a queen, you can see a queen has similarities. So this very clearly gives idea that we are talking about something more sensible. Now, France is to Paris as Italy is to Rome. You can see as Paris is the capital of France, so Italy is to Rome. This really works in a lot more interesting way. And there is one interesting research paper called Distributed Representation of Words and Phrases and Their Compositionality, where it clearly gives the difference between two different things. For example, Poland is for Warsaw, German is for Berlin, France is for Paris, Italy is for Rome, and Greece is for Athens. So these things really are important. Now, what we are coming to tell, the entire world, everything is mathematically fine-tuned. And if you are able to quantify this, that means if you are able to convert any problem into a number representation, then we can solve it. That's the power of math behind data science. Now, let's take a couple of examples here. So let me pause for a while and let me ask, is there any doubts till now? Any questions? Any questions? Okay. I think no questions as of now. Then we'll take it to the last. Now, now let's talk from the top point of how typically a data science job is. So for that example, I'm going to bring you a metaphor. That means a kind of story which can explain you about better. So meet Richard. So basically, Richard is the CEO of Simply Buy. It's a company which is similar to Amazon. Keep it like this. This completely virtual. You don't need to believe it, but for the understanding purpose. Richard is the CEO of Simply Buy. In order to build a reliable business, he has few requirements to the data science to make better decisions. Now, you know that Richard is the CEO of a company which is similar to Amazon, and he has appointed a data science team. Every day, he comes with new business questions and he put it in front of the team. They start solving it and find solution for Richard. So typically, let's see one day how it will be a day of a CEO and how will be a day of a data scientist. So he comes to the team and asks, can I know which product can sell together? Can anyone help our HR team to shortlist resumes faster and save time? Next, are the customer feedbacks about our products are good, or how are they across the geographies? Three questions he has. Now the data science team comes back to their place, which with all the three questions which Richard has already given. That is, can I know which products sell together? Can anyone help our HR team to shortlist resumes faster? What are the customer feedbacks about our products across geography? These three business problems they converted into data problems. That means from where data comes. For the first one, yeah, data can be retrieved from the Simplify inventory. Second one, candidate application can be retrieved from the job portal database of Simplify. Then what are customer feedbacks about our products? Data can be gathered from the by a form of hashtags or Twitter, Facebook, Instagram, all these things. Now let's take the first one, similar product recommendation. That means if I buy one product, what is the most similar product I can suggest? This is a slightly different way of recommending system. Let's take a list, a very simple list where you have every user's unique ID and the product they purchased. User 1 bought apple, user 2 bought orange, user 3 bought apple, user 4 bought grapes, user 5 bought milk, user 6 bought milk, user 6 bought grapes also, user 8 bought milk, user 9 bought apple, user 10 bought apple, and user 7 again bought orange. Like that, we have a list like this. What are the things they have purchased in a day or in a span of 1 week or 2 week time frame? Now I just transpose this table like this, like a one hot encoding. I'm taking all the users and putting them a name. Okay, for the easy understanding purpose, changing all their unique ID into names. And I took all the items available in the shopping mart as one column for each item. Now I'm putting a encoding representation. James bought apple. Yes, one. James didn't buy orange. James bought pineapple. James bought grapes, but James didn't buy milk. Likewise, for everyone, the one represent that product which they bought. Okay, and zero represent that it's not been bought. Now the same data, if I'm applying a very simple conditional formatting, now something interesting is happening. Some pattern starts coming out. You can see is that James uh, bought apple, pineapple, and grapes. Who is similar to James? My questions are, can I find who is similar to James, or who is similar to Jack, or who is similar to Gracie? Now that ends with some recommendation. James and Rick has similar choice. You can see James and Rick, they both bought apple. They both didn't buy orange. And James didn't buy milk, but Rick bought milk. So as their shopping list, 70% of things are similar, I can recommend what Rick bought milk to James. Gracie and Tommy has similar choice. She may like grapes as well. Mike and Danny has similar choice. You can say Mike and Danny has similar choice. They both didn't buy this. So that I can recommend whatever Mike bought to Danny also. This solves the problem of recommending similar products. Now come to the second point. Company like Simplify, they have a huge opening where every day they will get, I mean, like a pile of resumes. You can see typically per day they will get resumes like this. Now, but the HR team is very small. I cannot put in a ratio that total number of resumes I get equal with that ratio. I cannot increase my HR team. I have to be very consistent because I need to optimize business. So what will happen is like now the CEO has given the command that you should not skip any resume. You have to be very transparent. At least you have to screen it. Then only you have to take. Now this is a very big challenge. That too per day you get a pile of resumes like this. So how they solve the problem? They take the resume, which is in the form of PDFs, and they start scraping all the text inside that resume. And it is created as like one very big, bulky, meaningless sentences. I mean, like all the textual content. Ignore your photo, coloring, and everything in the resume. Only the text content. That comes in the format of a very big paragraph. Now I start removing all the stop words, the, is, and all the stop words from that paragraph. only keep the most important keywords. Now I'm giving a rate card. I mean like a scorecard. I'm telling if someone is having C++, give 5 marks. If someone is having Python, give 5 marks. Programming, 2 marks. MS Excel, 2 marks. Like that I'm giving a scorecard for that particular job role. Now the program will automatically go and find every single word and count total number of time it's there and how much time and what is the score for it. If it is 5, 4 times come, then that much score. So based out on that, we calculate a score called 23.5 for this particular candidate. Now, as we have written this as a program, I can run on a loop and I can generate a CSV file like this. That means a spreadsheet like this for every user, their keyword, and their scores. Within 10 minutes or even 10 to 15 minutes, this entire 1 billion resumes will get parsed and you will get a final outcome in the format of a table structure with a score. Now it's easy. I can go to the score and sort the column in descending, pick the top 10, call them for schedule them for an interview. But if I'm more interested on knowing little more deeper, you can get their information from other areas like social medias, etc. Now you can pick a column of choice and take the right candidate for the interview. So I have passed all the resume. Out of the, I picked only the top 10 who is more efficient for the interview. Different types of customer. You might have seen when you go to Amazon or Flipkart or any kind of these e-commerce or even Google, you and your friend both are sitting in the same room and searching for the same item in both of you are having your own phones. You're searching for the same watch in Amazon. The results will be totally little surprising. The result what you get will not be the one which your friend is getting. It will be slightly different. So that really is important because consider your phone is very small or your laptop screen is very small. Amazon will be having a billions of items in their inventory, right from your groceries till buying cars. Keep it like this. Now, in that small space, I should be able to very intelligently recommend you only things which you will buy. I cannot go and show you things which you don't buy. If I'm showing you things which you don't buy, you will easily get distracted because you need to go to long run for finding the product. You may skip that website and go to some other place and buy from there. This is a very interesting problem which will definitely increase your profit. So I need to be little intelligent on understanding who is a high paying customer, who is a price conscious customer, who is a quality conscious customer. If I'm having these questions and if I'm having the list of them, whenever they log into the website, I can only show the things which are relevant to them. If I'm showing relevant to them, they get interested, they buy more. If I'm showing things which are irrelevant, they easily skip and go. That is a big loss. How to solve this problem? So all these web application, I mean like all this e-commerce portal start collecting different data points about you whenever you visit the site, do anything on that. For example, when you click on an ad or how much time you click on one particular category of product, how much importance you give for price, how much time you use the filter, all this data is taken like this. Each person, every record is one person and their detail. So all this detail has been collected. Now if I apply very simple k-mean algorithm, ultimately it clusters me based out on similarity. All the 100 or millions of customers, it will cluster them into 4 different clusters. And that cluster will have something similar. That means all the people who comes under one cluster have something in common. If I understand what is that common, then I can push that particular type of product to that customer. Now, third problem solved. And one bonus problem, how to know whether our company's products are liked by people. We all are social animals. Right now, we live in a social media. So, whenever we buy anything, first thing what we update is before telling your parents, you start putting it in social media, whether it's a trip, travel, buying something, purchase, or your reviews, or anything, you post it there. Whenever you are little more getting educated on social media, you start using hashtags. Hashtag iPhone 10 shittiest product, as iPhone the best product, like that you start putting. Now if I want to know anything about any particular product, I can pretty much go and search for one specific product using the hashtag. If I put a hashtag, enter, I get all the tweets regarding that particular hashtag. Now I can scrape the content and do a sentiment analysis on every single tweet, positive, neutral, negative. Then if I plot it on a choropleth map, because every time when you tweet, your location is also there in the tweet. So when you plot it on a choropleth map of US, you can see customers overall 99%, 98 percentage people are happy across the country. Only there are two different places where people are giving negative. So as a CEO, I can directly call to that place and ask that, hey, what's happening here? Why it is going like this? I think there is some supply chain distribution issue with that. Sort it out. Else you are doing a very bad job. We are able to take decisions from data. So till now you have seen everything artistic, more data centric, visually applied aspects of data science. Now let's see data in action. So how many of them have seen Game of Thrones? How many of them have seen their Game of Thrones? I think most of people could have been big fans of Game of Thrones, right? Mostly, not everyone. So we worked out on Game of Thrones, and we created how can Game of Thrones really be helpful. Can you see a network here? This is a network, and I'm telling you openly, I have not seen Game of Thrones at all. Now I want to know how is Game of Thrones, what is this all about? Who is the most important characters and who is connected with whom? I have not seen the movie at all, but I have written scripts which start scraping through this entire series text. You are aware it's available. It's going through everything and it start creating a data set which is having, okay, how many times Tyrion has been speaking to whom, he's been referred by, like that. The text is being created, data set is being created. Now you can see a graph, very big graph in the screen, and every single point in this graph is one personality. You can see John and Daenerys, okay, Daenerys, Tyrion, Arya, and you can see the size of bubble represents how much important, how much frequently they have been referenced, and they are the most in this. The size of bubble represents how much important the characters. Even the sub character also you can see all small characters, who are they, etc. Now you can see there are few big bubbles and small bubbles. And if I go and click on any one bubble, I can see who is he very much connected to. Okay, this is whom Arya. Arya is mainly connected to John, and is connected to Tyrion, connected to Jamie, and Joffrey. Now, likewise, I can go and drill down every single personality, but I don't want this big mess. I want to remove all the small characters which are not important. I don't want these important characters. I just want to focus on the most important network. Who is the most important characters in this? I got a separate cluster. I can see here now John, Tyrion, Sansa, Joffrey, Sere, all are connected. If I pull him, who are the one who is more connected to him? If I pull this person, who is more connected? So what happens is this helps us to understand the underlying relationship between people, characters, personalities, or transactions, fraud detection. Likewise, it can go into a plethora of use cases where such kind of networks can understand the underlying principles behind the connections between different things. You can use it for finding most influential person in a community, or COVID point of view, in a pandemic point of view, contact tracing, who could have infected whom, how much. So all these things you can solve it. Now let's go to the next one. We worked out on an interesting aspect, that is, see, before this geo has come, geo or any of this network comes, we were very much attached to the what to say, the public wi-fi's, like when you go to a shopping mall, you start using public wi-fi's there. So this is typically of a public wi-fi in a Singapore based shopping mall. Okay. What we did is whenever you go for the shopping, you register there. Next time, even you go for window shopping, a router connects it and it start collecting the log of you be present there. Based out on that data, we want to see how is people movement across the stores. So if someone is coming from outside, the thickness of line represents the volume of people. The thicker it is, more number of people. You can see from outside, majority of people come to the fresh products. Known factor. Whenever our homes are located near to a shopping mall, 90% of time we prefer to take groceries from the shopping mall. That is what is seen here. So I can get everything in one shop. Now, second highest is general merchandise. Third is apparels. Okay, after they come to fresh products. Now the second place where they go more is meat, fish, and poultry. This is where a vegetarian versus a non-vegetarian debate come. Okay, fresh product point, you can see majority of non-vegetarian they go to the meats and fish, poultry. Known factor. Some vegetarians to ready meals, dairy, etc. Some goes to very rarely go to entertainment. Some goes to general merchandise. Some goes outside after buying it. You can see that line is also there. So across the malls, you can see people moving one to one, different places. And when I'm reaching to one particular place, the thickness is very high. That means people who are going out from this shop is very high. The attrition is pretty high. So the question is why it can be what can be that interesting thing? Why people stop their shopping after visiting the shop? So when we were looking more deeper into it, we were able to understand the nearest shop which is there to BWS is nuts and snacks. So BWS is nothing but beer and wine shop. So what happens is when people come for shopping, they don't want to directly go and carry the bottles all across the shop. So they keep in the last of their shopping list. So after doing all the shopping, finally they come to beer and wine section, carry the bottles, and that's where the shopping ends. They go back. That's what you can see here. So what we are seeing is a data is telling a story, which we are not aware of it. Very clearly, it's showing in a visual representation what's happening behind the scene. Now, what is the purpose of this? When you know how is the people movement across the shopping mall, you can distribute the shops in such a way that we evenly get every single customers across all the shop. Then only I make good profit out of this. Okay, interesting. Now, this is a interesting visual, which is a daily sales calendar map. So you can see a company or a product like Starbucks. You have a lot of counters in Starbucks, right? You can see there are unit 1, unit 2, unit 3, unit 4, 4 different locations. Starbucks is there. Consistently for first all 6 months, you can see first 6 months of the year. December, January, February, this time frame, you can see they have a very poor performance, but they are really good during March, April, May. Even unit 2 is similar to unit 1. They also have good time only during this time. Unit 3 is significantly better than it. Across all the season, they are better. And unit 4 is poor. Always it's poor. But one thing very interesting happening is only on Wednesdays, unit 4 is poor performer. But unfortunately or fortunately, only on Wednesdays, unit 4 tend to perform little good comparing to all other days. So you can see slight greenish. So when we look into what's happening behind the scene, we came to know the person who sits in this counter takes half a day on every Wednesdays. So people who come to this unit see that counter is closed. They go to the nearest counter and start buying things from there. That's why this redirected people is what we can see here. Now, why unit 4 is always underperformer? Because the location where the unit 3 is present has a pretty low population level. Most of the population, only unit 3 itself is able to serve them. So there is no purpose of unit 4 there. That's the reason people are less in that particular location, but there are 2 different outlets. So if I'm changing this outlet from this point to another location, I can make this outlet also equal performer. Good. Now we're coming to the last of this session. That is, can birthdays tell stories? Yeah, you can see this is a birth calendar of 1 year of US births. For example, January, February, March, April, May, June, July to December, and all the 30 days. The darker cell represents more number of births. Birth means deliveries. You can see exactly during New Year, births are very less, light color. And you can see a light stripe on 13th of every month. Every month, 13th, you can see number of births are less. It's superstition. People doesn't want their kids to be born that day. And they feel it's very auspicious day to have kids on February 14th, that is Valentine's Day. No one wants their kids to be born on April Fool's Day, and they feel St. Patrick's Day is considered to be a very auspicious day, and Independence Day, no births. Thanksgiving holidays, no births. Christmas holidays, less number of births. So rather than it's looking like a birth calendar, it's more looking like a holiday calendar. There is a there's a reason behind it. In US, 60% of births are C-section births. So whenever your delivery dates are overlapping on a holiday, doctor takes a decision, okay, let's push slightly forward. That's what you can see in that. So if US is this much superstitious, how is India? You can see after July, number of births are totally less. Okay, only the season are during April, Jan to July is high season, and that too especially during April, May, June, dark stripes. But an interesting thing which you can find is on all 5th, 10th, 15th, 20, 25, 30, the number of births are more. You can see the dark stripes on only on those days. These are all cooked up numbers. That means when people cook up numbers, they cook up with round numbers because it's easy to remember. All are fake birth dates. And you can see after April, September, these days also still that continues. Even though the births are less, still that pattern continues. Does it really affects their marks? So the same kids 10th standard marks were been taken and we cross correlated and compared it. What we found was the kids who are born after July, that is August, September, October, November, and December, they tend to perform much better than the one who are born during January to July. Not completely, partially. And the people who are having that fake numbers 5, 10, 15, 20, 25, they tend to perform even poorer than the one who are on the other days. There is a reason. For example, whenever you're going and putting the kids onto the pre-KGs, when you cook up numbers, you try to get an admission for an early stage of a kid. You're trying to put with a gang of kids who are already well developed in their, because maybe they have taken another the exact time of little more brain development has happened. You have taken your newborn kid as soon as possible, you want to go and put it into the pre-KG. That really affects their performance also. Like two different sets of people, and that is consistently followed up till their 10th 11th standard also. That's what you can see here. Now when you have data, now who is your audience? That determines the story. For example, if I'm giving a sales data set, three people, the company board, product head, sales head, all three different roles of people will be having different questions on the same data set. The board will be more interested on knowing what is our predicted quarterly sales. Product head, which products grows the most. Sales head, did we meet our target? They are not interested in each other's question. Who is your audience for your analysis? That you need to know. Find the role. Be very specific. Head of sales, vice president, CEO, like that. Example, name of that person, Jim Fry. Don't put any fake name. Put the real person name. Now, what is their problem? That defines your analysis. For each person, answer the following question. That is, what's their situation? What problem do they face? What action can be taken? What is the impact of the action? Example, as you can see, this is like a filling the blanks. This template, you can take it and keep it. Every time you need to fill these orange place exactly like how is shown here. John, the marketing head, person and role is defined. Must create a region-wise budget. That's a situation. And doesn't know region-wise ROI, return on investment. That's a problem. By prioritizing the region, that's the action, he can maximize the ROI. That's the impact. Now, when you do this, you will get a list of analysis and you should be able to filter your analysis using three different filters. That is BUS, bus filter. It's called, is the insight big? Is the insight useful? Is the insight surprising? The example is, you have to put this filter. There are twice as many restaurants in New York City than any other city. Is it big? Yes. Is it useful? Yes. Is it surprising? No. Sales increased in every region except our largest branch, which is a dip by 0.1%. Is it big? No. Is it useful? Yes. Is it surprising? Yes. Increase in rainfall increases the sales of umbrellas, and it is the biggest driver of sales. Non-factor. It's a big impact, but it's not useful or surprising. Now, we have to understand data is our real hero. And if you are becoming a data centric person, it's going to really change your complete way how you solve data science problem. And data science is not only about ML and DL. Machine learning is a very small set of this big ecosystem. Okay, so don't only focus on machine learning. Try to understand, analyze data, explore data very well, and business the business outcome is more important than ML, TL, and NLP. Even you can use and solve a paper and pen to solve any kind of problem, but the business outcome should be the target. By this, let me take a pause. I have a small feedback form I would share in this. You can, or I'll just share to the madam. So you can put your feedbacks. Now I'm open for questions. So you can post your questions. Okay, there is one question. What is the difference between data profiling and data mining? See, data profiling is seeing your existing data. You're taking your data set and understanding, okay, what are the columns I'm having? What are the, how many columns I'm having? What are the records? Whether my data is clean, whether my data has, what is the distribution of it? That's data profiling. Data mining is exactly like going and drilling down and finding something interesting from that. Whatever you have seen here, any insight, anything which will add value to your business, you are using data mining techniques. That's called, that's a major difference. Profiling is different, data mining is different. So no questions for me? I can keep this.
Yes, participants, any more questions?
No questions? Okay. In data science, we do data cleaning. Absolutely, yes. In data science, it's more of first you clean the data, because 90% of time is on cleaning the data and normalizing, standardizing your data. Then only you can start analyzing it. Else, you will be doing something wrong where finally your outcome won't be correct. Or even if your outcome is there, you won't be able to take a sure decision that it's correct. Okay, what are the fields in data science than ML and AI? See, data science has like data storytelling, data narrative, data visualization, data literacy, data lineage, and machine learning, deep learning, neural networks. Deep learning and neural networks are same. NLP. So we have different fields in data science and mainly data analytics. Great, great. I'll keep my image again. So yes, I'll share it and keep it. So if you have an interest or on working or you want to get more insights onto it, you can connect to me on LinkedIn, and this is my LinkedIn profile. Or that's my email ID. You can reach to me. Now open for the questions. Can you suggest platforms to study? Platform in the sense, can you just clarify that, Yuvraj? Okay, Nikita has asked a very interesting question. That's absolutely correct. What level of statistical knowledge is needed and any reference? I will say data science is the old wine in the new bottle. Those days we call data science as statistics. Today it is called data science because those days the data size was pretty much nominal. We were doing it in paper and pen. Right now we are doing the same data in computer because the size has grown up. So whatever I will say, 90% of things what you're doing in data science is statistics, and that is specifically on descriptive statistics, inferential statistics, and these are something which you need to know more. Then exploratory analysis is fundamental. So it's not like we go and learn Python and R and tell, hey, I'm a data scientist. That's not possible. You are a software engineer. So when normally when even this is a real big misconception, even people who come from IITs to our organization when they're working, they come with the idea that model building, machine learning is a fine. So when they work under me, the first question they ask is like, "Sir, which model should I really focus on?" I say, "Did I ask you to build a model first? First, you have to analyze the data, build a strategy, understand how much you can trust your data. For that, you have to do data auditing, data profiling, everything needs to be done, and make sure that yes, I have enough data so that I can take a decision out of it." So Nikita, I got, I think, and the best reference are like, yes, I can. So can I share a link, like how to share a link here, Manali?
Yes, sir, you can drop a link.
I think I don't, I can't see a place to share the link, so I can, I'll do one thing, I just create a bit short URL, and you can
Sir,
just
you can
reach to
post
me.
it in a private chat.
Okay.
Yes.
Okay, this is the one. Yeah. Okay. Fine. 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 That's the form. Okay. You have already share the form. That's no need. You can skip that. And I can put my
Yes,
LinkedIn.
sir.
So feel free to connect through that. And I'll basically we have a data community being building, and we have a lot of data practitioners there. So if anyone want to be a part of it, we'll add them there. Not a problem. So more questions. Okay. Uh, Can you share most important resource? Absolutely, ma'am. Like Smita, definitely I'll do that. And should coders have a sound knowledge of R and other statistical? How a BCA student should approach? See, knowing programming is it's definitely a plus, but it doesn't mean that's the only plus. You can be a great programmer but zero analyst. Same way you can be a great analyst with zero programming knowledge. So it's hypothetically there are a lot of difference inside that, and the end is about how much you know the business, and you should only use programming whenever it is needed. It's not that there is a saying like when the only tool which you have in your hand is a hammer, everything seems to look like a nail. So don't look data science from a programmer perspective. Look it from an analyst perspective. How to solve the problem that can be solved even using an Excel. So programming will definitely help you to do the data cleaning and some level of automations. Okay. So, any more questions? I can see that my link has been shared. Great.
Please, participants, any more questions? Okay.
I think all are done.
Yes, I guess all are done. So let's continue with the further part. So thank you so much, sir. It gives me the immense pleasure to deliver a vote of thanks to all the dignitaries gathered together for this event. First, I would like to thank to our eminent speaker, Mr. Bastin Robin, for conducting the informative session and also for illuminating our participants with your knowledge, ideas, and experiences on the pathway of becoming a data scientist from being a good data practitioner. We are thankful to both the speakers for enlightening and presenting our participants with the data driven decision science. Now, I would like to thank everyone involved in making this event successful. A successful event has many hands working effortlessly for months. A very big thank you to our in charge principal ma'am, Dr. Teresa Joseph, Chief Education Officer, Dr. Mala Kakar, Chief Coordinator, Mrs. Ruchita Darvi, and management members for supporting us and giving us the opportunity to conduct the event. I would also like to thank our BSCCS coordinator, Mrs. Namrata Kavle, our BSc IT co-coordinator, Mr. Chayan Bhattacharjee, and Ms. Pooja Shinde for their constant guidance and encouragement. I thank all the faculty members at the Department of Information Technology and Computer Science involved in making this event a huge success. Last but not the least, thank you to all the participants for enthusiastically participating in the program. We, we look forward to continued associations for years to come. Before concluding the event, I would like to give few instructions to our participants. Feedback link will be posted in the chat box, so please give your valuable feedback. E-certificates will be sent on your respective email IDs within 4 to 5 days. With this, I conclude the RUSA sponsor international webinar Research in IT Data Driven Decision Science. Thank you once again. Good day, stay safe, stay connected, and keep learning. Thank you, everyone.
Thank you. Thanks, everyone. So, before I wind up, I'll say like be more of a data centric person than running behind every tool available. First, you be very strong with data, and that should be the key takeaway of this entire event. Thank you.
Yes, thank you, sir.